This
Yeah,
conference will now be recorded.
a very good morning, afternoon, and evening to everyone present here. And let me introduce myself. I am Emma, to the organizer for day two. And if you have any queries relating to presentation or anything, you can ask me or write in the chat box. As I can see, some of the presenters are new today, so I will just give a brief description about the GoToMeetings app. So on logging into your screen, you can find four icons at the bottom of your screen. That is, the first one is mic. Click on that to mute or unmute yourself. So I request you all to stay muted while our speakers are presenting their research work so that it doesn't cause any disturbance to them. Camera, you can use this button to share or unshare the webcam. If you have the option, you can share that, or else it's completely your choice. Screen, you can use this button to share your screen, and this is the main part. At your schedule, when I will call for your name from my side, I will be making you the presenter. When I will give you the access to share your screen, then you need to click on this button and you will find a pop-up window which will ask you to share the screen and you can proceed further. For MacBook or Apple device users, once I make you the presenter, then you need to give the permission to share the screen in your system preferences. After that, you need to log out from the session and need to join again from the same link and share screen for the presentation. And last one is the leave. On clicking this button will leave you from the session. On the top right corner, we have four options. One is the people, which shows you all the attendees of the conference. Second one is chat. In this option, you can chat with me or any other participants for any queries. Third one is notes, to write down your notes of your own. And fourth one is settings. You can use this button to check for the settings of your speaker and microphone. So as mentioned, kindly remain muted during the presentation so that the presenters who is presenting don't get disturbed. And for any questions, you can ask me or you can write in the message box too. So let's move on to the sessions. And our first presenter for today is Dr. Sequen Fang from Chinese Academy of Science from China. And the title of the talk is Sulfur Poisoning on RH Nanoparticle but Sulfur Promotion on Single RH1 Site for Carbonylation. Hello, Dr. Sequen. Are you ready with your presentation?
Yes, thank you.
Okay, yeah. So you are the presenter now. Can you please click on the screen icon? I mean, share icon.
Okay. Hello. Can
Yes.
you can you see it? This
No,
is
no,
my
it's not visible. No. Are you using the MacBook?
yes. I use the MacBook
Okay,
and
then what you need to do is you need to first log out from the session after giving the permission in your system preferences. Then again you have to log into the session. Then you can able to share your screen.
but I can't share my desktop.
Yeah, first you need to give the permission in your system preferences. Did you give that?
Okay, maybe I need to.
Yeah, you need to go to the system preferences. You need to allow the share the screen. Okay.
This conference will now be recorded.
So, in the meanwhile, as Dr. Sipin attend, so we will proceed to the next presenter. If Dr. Felix is available to present the talk, okay. Dr. Sipin has entered the program.
Sorry, everyone. My internet
Yes,
lost.
yes.
Thank you very
Okay, no
much.
issue. Yeah, so you are the presenter now. Please click on the share icon.
Yeah, I will share my PPT. Can you see my PPT?
No, it's not visible. Did you click on the share icon?
Sorry, I can't share my desktop. Why?
Yeah, after clicking on that, what is showing? Can you please let me know?
Yes, I clicked it. I clicked it.
Okay. Yes, can I know the issue?
it, it didn't work.
Okay, so what you can do is, can you send your presentation to the program manager so that we will share the presentation and you can explain from there?
Okay, I can send it
Okay,
to.
you can send to the program manager and we will
Yes,
share the screen for you and you can just
yes.
let us know when we have to change the slide, we'll do that.
Okay, okay,
Okay, so once you have sent, just let us know.
okay. I will send it at once.
This conference will now be recorded.
Hello. Hello, Dr. Sequin. Did you send the presentation? Okay, as the program is getting delayed. So, Dr. Sequin, you can send the presentation to the program manager. We will take it from there and we will proceed further. In the meanwhile, we will proceed to next talk. That is from Dr. Felix Panis. Hello, Dr. Felix.
Hello.
Yeah, I'm sorry for this delay. So, are you ready with your presentation?
Yes, I'm ready.
Okay, perfect. Then I'm going to make you the presenter. Yes, so please share your screen with us. Okay, I don't know. Dr. Felix also left the session. So we will move to the next presenter. So next is Dr. Rajesh Kumar. Are you ready with your presentation? Hello, Dr. Rajesh Kumar. Your voice is not audible to us. Can you please unmute yourself? Can you please click on the mic icon? I'm sorry, it's not
Like
audible to
my
us.
presentation is ready.
Yes, yes. Okay, now it is okay. So I'm going to make you the presenter.
Yeah.
Yes. Yeah, please share your screen with us.
Okay.
Yeah, it is visible. So now you can open your presentation.
Okay. It is visible.
No, now it is not visible.
Okay. Mhm.
Yes, now it is your screen is visible. Can you please open the presentation? Actually, when the pop-up will come, you need to allow all the screens to access and to share with us. That's the reason your PPT is not visible to us.
It is visible.
No,
Visible.
no. Yes, yes. Now it is visible. Can you make it full screen?
Yeah. It is visible.
Again, no. Yes, yes. Now it is visible.
Oh. I would like to thanks organizing committee who give me an opportunity to present my research work. The topic of my presentation is biocatalyst mediated synthesis of modified nucleosides. Here we discuss the synthesis of modified nucleosides with the help of biocatalyst. That is, here we use lipozymes. Uh, as we know, enzymes are very specific. It can occur under mild condition. It can also occur in water solution or non-water aqueous or non-aqueous environment. It can be used many times. Very mild conditions are required. Today we discuss two types of nucleosides. The first is spironucleosides. There is one extra ring, four-member oxygen ring directly attached C4 prime carbon atom. That's why it restricts conformation flipping, enhance biological activity. And second is the locked nucleosides. There is one extra ring, 2 prime and 4 prime. There is one 5-member extra ring between 2 prime and 4 prime carbon atom. That's why it restricts conformation flipping, enhance biological activity and selectivity. First is the spironucleoside. Hydroxycidine is the first naturally occurring spironucleoside. It is also known as herbicidal and plant growth regulatory activity, and it shows biological activity. To achieve better activity and selectivity, time to time, different scientists have synthesized different types of spironucleosides. That is C1 prime spironucleosides, C2 prime spironucleosides, C3 and C4 prime spironucleosides. Packet group synthesized C4 prime spironucleosides, and Massa group has synthesized C1 prime spironucleoside. Later on, Mandal group has synthesized C4 prime spironucleosides, and Wenkal group has synthesized C2 and C4 prime spironucleosides. Our group has also synthesized C4 prime spironucleosides. These are the biologically active spironucleosides. This is hepatitis C virus. Different types of biological activity, different types of spironucleosides have shown different biological activity. Later on, we discuss locked nucleoside. First of all, Jesper Wenger and Takeshi Imanisi introduced the concept of locked nucleic acid. There is one extra ring between 2' and 4' carbon atom. LNA is that's why it is called an analog nucleic acid. There are two types of conformation: S-type conformation and N-type conformation. LNA is the single nucleic acid modification that contributes to the highest affinity ever obtained by Watson-Crick hydrogen bonding. This is the normal cell. This is DNA. DNA convert into a messenger RNA. Messenger RNA convert into protein. If you synthesize a specific sequence or bind with messenger RNA, that technology is called antisense technology. And if oligonucleotide binds with DNA, forms triple helix, stop the formation of messenger RNA, that technology is called antigen technology. There are two types of technology: antisense and antigen technology. Next question is why we modify nucleic acid. There are some limitations. Since 1978, over 3,000 publications have focused problems such as poor nuclease resistance, low cellular uptake. That's why we need modified oligonucleotides. Modified oligonucleotides should have high resistance to nuclease, should be water soluble, enhance cellular uptake, hybridized with high affinity, especially towards target messenger RNA. That's why we need synthesis of modified nucleosides. These are the modified oligonucleotides that are running in the market: Vitramine and Kinemro. Kinemro is the cholesterol reducing drugs which is running in the market, and Vitramine is the ATNs. These are the current clinical trial drugs. This is the miravircin, is the hepatitis C virus, is under clinical phase 2. EZN 2968 solid tumors. The EZN 3042 is a cancer treatment. EZN 417 is a cancer. These are the under phase 1 trial. This is the synthesis part. We synthesize modified nucleosides with the help of simple sugar. We know sugar is very cheap and easily available in the market. We started from protected sugar and synthesize. This is the key precursor and synthesize different types of modified nucleoside. This is the LNA in ribo configuration. This is the spiro in xylo configuration. This is the xylo LNA, and this is the ribo LNA and the spironucleoside. First, chemoenzymatic synthesis of 3' azido amino ribo log nucleic acid monomer. We started from protected sugar with the help of benzyl bromide is a protecting group in basic medium. Protect this hydroxyl secondary hydroxyl group with the help of benzyl bromide, and in the second step isopropyline ring is opened with the help of 80% acetic acid. Then after oxidation with the sodium periodate we get this aldehyde, and with the help of formaldehyde we get Cannizzaro reaction, and we get diol compound. After that, with the help of acetic anhydride, we get a silated product, and palladium charcoal devenzylation, we get monohydroxy compound. With the help of triflic anhydride as a protecting agent and sodium azide, we get inverted azido compound SN2 type reaction. In the next step, hydrolysis of acetyl group with potassium carbonate in methanolic aqueous methanol, we get dihydroxy compound. Here is we use Novozyme 435. We can see there are two primary hydroxyl group, but Novozyme only goes this hydroxyl group as selective acetylation occurs this hydroxyl group with the help of vinyl acetate as a silating agent in toluene solvent, and we get 99% yield. After that, this primary hydroxyl group is tosylated with tosyl chloride, and this isopropyline ring is open with the help of acetic anhydride, acetic acid, and sulfuric acid. We get triacetoxic compound. This is the anomeric carbon. Nucleobase coupling occurs this anomeric carbon, and with the help of different types of base, thymine, uracil, cytosine, adenine, we get coupled this compound. After that, with the help of in basic medium we get LNA, azido-LNA compound. With the help of pyridinium charcoal, this azido compound converted into amino compound. I will get amino LNA monomer. During synthesis of selective acylation, we use different types of enzyme. There's a Novazyme, 435, lipozyme, TLIM, CRL, PPL. Out of these enzyme, only Novazyme is selective in toluene solvent. This is the crystal structure of tosylated compound, which is confirmed by X-ray crystallography. Now, second is the chemoenzymatic synthesis of 3' azido amino ribo spironucleosides. All steps are similar. Only difference is here. We can see here. You can see here there are two acetoxic group, two similar acetoxic group. Novazyme with the help of N-butanol as a acyl acceptor in THF solvent. Selective deacylation occurs with this acetoxic group and we get monohydroxy compound, and with the help of tosyl colloid protected will protect this compound and a ring opening of isopropylidene ring, we get anomeric carbon triacetoxy and base cup nucleobase coupling, we get nucleosides. In the basic environment, acetoxic group convert into OH and this OH acetoxic group आपस में we cyclize, we get oxyteno spironucleoside, four member oxyteno spironucleoside. First acetoxic group hydrolyzed into OH. OH attack on tosyl group and cyclize, we get oxyteno spironucleoside. Further reduction of N3 with the help of platinum charcoal, we get amino spironucleosides in excellent yield. Here we use different types of lipase and solvent. Out of this enzyme, only we can see only Novazyme is selective in THF solvent. In previous case, toluene was selective, but in this case, THF was selective for this reaction. This is the tosylated compound of this compound. Now, second is the chemoenzymatic synthesis of 3' azido amino xylosporidinucleoside. In previous case, we saw ribonucleoside. Now we can say xylonucleoside. We started from simple protected sugar. With the help of phosphorus pentoxide is an oxidizing agent. This hydroxyl group oxidizes into ketonic group, and with the help of sodium borohydride is a reducing agent. This ketonic group reduced into hydroxyl group and inverted configuration. Then protected this hydroxyl group with the help of benzyl bromide and ring opening of this isopropylidene ring will get dihydroxy compound. Then further acetylation we get diacetoxic compound. Then debenzylation with platinum charcoal in ethyl acetate solvent we get monohydroxy compound. Then triflation and azidation we get azido compound in inverted configuration in xylo configuration, and hydrolysis of acetoxic group with potassium hydroxide we get dihydroxy compound. Now you can see here there are two types of similar hydroxy group. In this case, lipozyme is selective for acetylation in diisopropyl ether solvent. In previous case, Novazyme is selective, but in this moiety, lipozyme is selective in diisopropyl solvent. We get selective acetylation of this compound. With the help of tosyl chloride, we get tosylated compound and a ring opening of this compound, isopropylidene ring. We get anomeric carbon and nucleobase coupling. We get nucleoside, and with the help of basic medium, this acetoxic group convert into OH and OH attack on tosyl group. We get oxytenonucleoside. Further reduction of N3 with platinum charcoal, we get amino spironucleosides in good yield. And this is the last synthesis. This we types again here we use different types of enzymes and solvent. We can see here lipozyme is selective in diisopropyl solvent. No, in this case, Novazyme is not selective. CRL and PFA did not perform any reaction. This is the crystal structure of this compound, and this is the last synthesis of my presentation. This is the chemoenzymatic synthesis of xylo LNA monomer in xylo configuration. We can see here hydroxyl monohydroxyl group with the help of phosphorus pentoxide and sodium borohydride we get inverted OH For the protection of OH with benzyl bromide and ring opening of isopropylene ring, we get dihydroxy compound. With the help of a silating agent in dichloromethane solvent, we get diacetoxic compound. And for the debenzylation of OBN group, BN group, we get monohydroxy compound. For the with the help of triphyllic anhydride, we get OTF, and agitation, we get N3 compound in xylo configuration. Now we can see here there are two types of acetoxic group, and in this case lipozyme is selective. A selective deacylation occurs this acetoxic group, and the acetoxic groups remain. With the help of N-butanol as acyl acetopter and diisopropyl solvent, we get 99% yield within 1 hour. And then further tosylation of this OH group, we get monotosylated compound, and ring opening of isopropylene ring, we get triacetoxic compound. A further nucleobase coupling, we get nucleoside. And in basic environment, this OH acetoxic group convert into OH attack on acetoxic group, we get LNA, xylo LNA monomer, azido xylo LNA monomer. With the help of platinum charcoal and ethyl ester solvent reducing agent, we get amino xylo configuration LNA. Here we use different types of enzymes and solvent. Lipozyme in diisopropyl ether solvent. Out of different solvent, diisopropyl ether is selective in a lipozyme TLN enzyme. This is the crystal structure of this compound. Now we can say this is the simple mechanism of how enzymes works on selective acylation and deacylation. And enzymes, we know enzymes have aspartic acid, histidine or serine. This is a simple deacylation mechanism and acylation mechanism shown by the diagram. Now we can conclude over all a reaction. Now we can see here there are two types of hydroxy group. Novazyme is selective in toluene solvent. We get monoacetoxic compound, and finally converted into ribo-LNA monomer. In this case, two acetoxic compound. Novazyme is selective in tetrahydrofuran solvent. A monodeacetoxic compound get, and with the help of tosylation we get spiro-ribo-LNA monomer. In this case, two types of toxic compound. Lipozyme is selective in diisopropyl solvent. We get monohydroxy compound, and further get xylo LNA monomer. In this case, two hydroxy compound. Lipozyme is selective in diisopropyl ether solvent. Selective acetylation occurs here, and further we convert spiro-xylo LNA monomer. This is the overall reaction. Now we can say enzymes are very selective. In one reaction, one enzyme is selective. In one reaction, other enzyme is selective. This is my research work. I would like to thank Professor Ashoka Prasad, University of Delhi, and RDS College, Bihar University, India. Thank you. You have any question? Any question?
Thank you, Dr. Rajesh, for your presentation. So, any questions from anyone? Okay, no questions. Thank you once again for your presence and presentation.
Thank you. Thank you.
So we move on to the next presenter, that is Dr. Felix Panis from University of Vienna, Austria, and the title of the talk is Tyrosinase in Wetlands: Global Contributors to Climate Change. Hello, Dr. Felix.
Hello, hello. Can you hear me?
Yeah, are you ready with? Yes, yes. So you are the presenter now. Can you please share your screen? Yeah,
Okay,
it's
so I
visible
think it
now. Yeah,
worked.
perfect. Yes. Yes, perfect. You can start presenting.
Okay, so hello everybody and welcome to my presentation, which is called Tyrosinases in Wetlands, Global Contributors to Climate Change. So first, let's have a look at what wetlands are and what tyrosinases are and what all of this has to do with climate change. So wetlands are globally distributed ecosystems. They are present on the northern hemisphere as peatlands mostly, and also present on the southern hemisphere, for example, as mangrove forests. They are characterized by constantly or seasonally waterlogged soil in combination with plant growth. Due to the waterlogging, they exhibit predominantly anoxic soils, and they represent unbalanced ecosystems. Despite wetlands cover only around 3% of the global land surface, they store 20 to 30% of the world's soil carbon, and this amount of carbon is equivalent to 66 to 72% of the amount of carbon which is dissolved in the atmosphere, mostly as CO2. So as you can see, wetlands are in fact globally significant stores of carbon. How have wetlands been able to accumulate these vast carbon stores? So in wetlands, CO2 is sequestered from the atmosphere via plant photosynthesis, and this carbon is then stored as in the form of complex organic molecules as biomass. And over time, this biomass is transformed to necromass, and this forms the soil organic matter. And in most soil, this soil organic matter is then degraded by hydrolysis, and carbon stored in this soil organic matter is thus released back into the atmosphere again as CO2. In wetlands, however, there are usually high concentration of phenolic compounds, and these phenolic compounds act as unspecific enzyme inhibitors, so they are capable of preventing the activities of a broad range of enzymes, including hydrolases, which normally would be responsible for degrading soil organic matter. Phenolic compounds originate from plant secondary metabolism and are leached into the wetland environment and are very recalcitrant molecules which can only be degraded by a very small set of enzymes, which are often grouped under the umbrella term of phenol oxidases. However, phenol oxidases is not a very precisely defined term and encompasses several not really known enzyme classes, but all of these phenol oxidases mandatorily require molecular oxygen to enzymatically remove phenolic compounds. In wetlands, however, oxygen cannot enter the soil due to waterlogging. As a result, there are anoxic soils and phenol oxidases cannot be active. As a result, phenolic compounds can accumulate in wetland ecosystems, hydrolases are efficiently inhibited, and soil organic matter cannot be degraded, and therefore, over the last millennia, wetlands have been able to accumulate these vast stores of carbon, which are currently stored in wetland ecosystems. Due to climate change, however, drying up of wetland ecosystems has become a likely scenario, which can also be observed in some ecosystems already. And if this happens, oxygen will be able to enter into the soil. This will increase the activities of phenol oxidases. As a consequence, phenolic compounds will be removed efficiently and hydrolases will not be inhibited anymore. And those vast carbon stores will therefore be degraded, and carbon currently stored in wetland ecosystems will be released back into the atmosphere as CO2. And this, of course, would further promote itself climate change. And therefore, this cycle of carbon storage in wetland ecosystems is really of global significance. Now let's see what tyrosinases are. They are type 3 copper proteins which have two copper ions in the active center. And they are oxidoreductases, which are capable of hydroxylating and oxidizing phenolic compounds to the corresponding quinones, as you can see here on the right. And these quinones are very reactive molecules which spontaneously and non-enzymatically polymerize, which finally leads to the precipitation and the removal of these quinones. However, tyrosinases mandatorily require molecular oxygen, so if there is no molecular oxygen available, tyrosinases cannot be enzymatically active. They are distributed quite broadly in nature amongst bacteria, fungi, plants, and animals, and even humans express a tyrosinase, which is responsible for melanin production and UV protection. Now, if we go back to this slide, which shows carbon cycling in wetland ecosystems, our research has been focused on the question if tyrosinases are key enzymes grouped under this umbrella term of phenol oxidases, which are responsible for controlling the concentration of phenolic compounds in wetlands and therefore the stability of soil organic matter stored in wetland ecosystems. So to tackle this puzzle of carbon storage in wetland ecosystems, we focused on three main questions. First, we wanted to see if bacteria, which are indigenous to wetland ecosystems, are capable of producing tyrosinases. And just as a quick notice, we focused on bacterial enzymes since the microbiome of wetlands has been shown to be dominated by bacteria in contrast to, for example, fungi, and therefore we use bacteria as a starting point. Second, we wanted to see if tyrosinases produced by bacteria indigenous to wetland ecosystems can be active in an extracellular wetland environment. And as a third question, we wanted to see if phenolic compounds, which are naturally present in wetland ecosystems and which are therefore involved in the inactivation of hydrolases, if these phenolic compounds are accepted by tyrosinases as substrates. So to start out with the first question, we went to a wetland in Austria, which is called Lake Neusiedl, which you can see here on the left. And this Lake Neusiedl is a shallow soda lake, and we collected peat samples from the reed belt of this wetland. And we used these soil samples to extract metagenomic DNA. So metagenomic DNA is genomic DNA from various organisms. So you have many genomes present in this metagenomic DNA extracts from organisms indigenous to your sample. And we use these metagenomic DNA extracts as templates for PCR experiments. And during these PCR experiments, we use the generated primers, which have been designed to specifically bind to tyrosinase sequences. So if you look at genes coding for tyrosinases, then you have some non-conserved regions and you have some quite conserved regions, which are very specific for tyrosinase enzymes. So our primers have been able to bind to these conserved regions and amplified everything located in between, or specifically amplified everything located in between those two regions without amplifying any other genes. And this covered or covers approximately 50% of the full-length tyrosinase sequences. Then we did a blast search with our identified partial sequences and verified that we actually identified tyrosinase genes. And interestingly, for one of our blast search, we found a 100% match deposited in the UniProt data bank. So for this one sequence, we've been able to obtain the full-length DNA sequence, and for 18 other sequences, we've been able to obtain partial sequences. And this demonstrated the tyrosinase gene containing bacteria are in fact indigenous to this wetland in Austria. However, we were interested in seeing if this is just a local observation or if this is actually a global phenomenon. And we also wanted to know more about the host organisms of these tyrosinase enzymes, but we couldn't get any information on the host organisms by our metagenomic DNA-based approach. So we did a literature search and we started by searching the UniProt data bank for bacterial tyrosinase genes. And in the UniProt data bank, you have genes coding for various enzymes which have been uploaded. And many of these genes have been previously identified by genome sequencing projects. So in a genome sequencing project, the whole genome of an organism is sequenced and all of the information with thousands of genes is uploaded. And then an algorithm can automatically detect genes and can also annotate functionalities. So you have enzymes with annotated functionalities and the corresponding host organisms, which are uploaded to the UniProt data bank. And we've been able to identify 9,000 entries for bacterial tyrosinases. And we filtered all of these enzymes and checked if the host organism of the respective tyrosinase has previously been reported to be indigenous to wetland ecosystems. And in fact, we found 145 tyrosinase sequences, which are present within the genomes of bacteria, which are indigenous to globally distributed wetland ecosystems. The ecosystems to which the host organisms are indigenous were located, some in high Arctic regions, some in tropic regions, some in between. So this really demonstrated that globally distributed ecosystems and also different types of wetland ecosystems actually contain bacteria which are capable of producing tyrosinase genes. We also built a phylogenetic tree, which you can see here, of the 145 identified tyrosinase partial sequences to group them according to the phylogeny. And this demonstrated that most sequences originate from actinobacteria, and this itself is quite interesting since actinobacteria commonly express enzymes which are physiologically secreted into the extracellular environment and can therefore be very active on the ecosystem or the habitat. So in summary, this data demonstrated that in fact tyrosinases or genes coding for tyrosinases are present within the genomes of bacteria which are indigenous to globally distributed wetland ecosystems. So next, we wanted to see if these tyrosinases produced by bacteria indigenous to a wetland can also be active in the respective wetland environment and if they can show activity under conditions found in their ambient wetland environment. So for a start, we started with a literature analysis and we just wanted to see if in principle or for which wetlands in principle tyrosinase activity can be expected or with which wetland ecosystems tyrosinase activity is in principle compatible. And so we compared the pH values of various wetland ecosystems which are shown on the left, and you can see that approximately the pH values range from pH 3.5 to 9. And pH is a very critical factor with tyrosinases since they are only active in a certain pH range. And so we wanted to see for which of these ecosystems, in principle, tyrosinase activity can be expected. And so we also collected the pH optima of previously biochemically characterized tyrosinases. These enzymes originate from non-wetland sources, but we just wanted to see which pH range is covered by different tyrosinase enzymes. And actually we found that in principle, all wetland ecosystems, which are listed here on the left, have the potential of exhibiting tyrosinase activity in terms of pH. Of course, we wanted to prove this observation or this theory in practice. So we went back to our wetland samples, and as I've already mentioned previously, for one enzyme, we have been able to collect a full-length DNA sequence. So we've been able to identify the full-length sequence coding for this one enzyme, which is called S-tyrosinase, which is present within the genome of a bacterium indigenous to this lake Neusiedl. We've been able to develop recombinant expression and purification protocols, and this yielded to the production of active acid-tyrosinase in high purity, as you can see here on the right, and in good yield. So as a next step, we could use this enzyme for biochemical investigations. And we started out by investigating the pH profile of this acid-tyrosinase, which is here the picture on the left. And we found that acid-tyrosinase shows highest levels of activity at a the pH range of around 9 to maybe 10. And this is actually quite high for bacterial tyrosinase. So we went back to our wetland in Austria, to Lake Neusiedl, where the host organism of this enzyme has been identified. And we measured the pH of this wetland. And interestingly, we found that this wetland also has a pH value of 9 to 9.5. So of course, it can be expected that acid-tyrosinase shows high levels of activity in its natural environment of this wetland in Austria. And curiously, this acid-tyrosinase represents an enzyme that is physiologically secreted into the environment. So you can really expect that if this enzyme is produced, it would also be very active in the natural habitat of its host organism. So regarding the second piece of the puzzle, we have been able to establish that tyrosinases can in fact be active under environmental conditions which are found in the natural habitats. As a third question, now we wanted to see if these enzymes, which are produced by bacteria indigenous to wetland ecosystems and which can be active in an extracellular wetland environment, if these enzymes also accept phenolic compounds which are naturally present in wetland ecosystems. So if they accept these compounds which are actually responsible for inhibiting the activities of hydrolases and which therefore secure the stability of organic carbon stored in wetlands. And again, we started out with a literature search, and for a start, we collected all substrates which have previously been reported to be accepted by tyrosinases, and these are the substrates in the blue circle. And as you can see, this covers quite a broad range of compounds. So you have monophenolic compounds, diphenolics, triphenolics. You have cinnamic acid derivatives, benzoic acid derivatives, flavonoids. You have halogenated compounds. So this showed to us that tyrosinases accept a very broad scope of phenolic substrates. And in the next step, we did a literature search to find out which phenolic compounds have previously been reported to be present in wetland ecosystems. And we found actually that many of these substrates, which are naturally present in wetland ecosystems, are also potential tyrosinase substrates. Interestingly, one group of phenolic substrates, which is commonly observed in wetlands, but which is not accepted by tyrosinases, are methoxylated substrates. So they are probably not involved in carbon storage. So we wanted to prove our hypothesis again in practice. And we went back to our wetland samples from Lake Neusiedl and our recombinantly expressed tyrosinase, this SZ tyrosinase. And we already knew from previous investigations that all of these compounds, which you can see here on the top of the slide, are naturally present in this wetland ecosystem. So they are naturally present in the natural habitat of the host organism of SZ tyrosinase. Next, we did activity tests, and we tested towards which of these substrates SZ tyrosinase shows activity, or if it does show activity at all. And we found that, yes, it had activity to caffeic acid, gallic acid, picomaric acid, and protocatechoic acid. So in conclusion, we have first been able to demonstrate that tyrosinases are present within the genomes of bacteria which are indigenous to globally distributed wetland ecosystems. Second, we have been able to demonstrate that bacterial tyrosinases have the potential of showing high levels of activity in their natural wetland environment. And in a third step, we also have been able to demonstrate that phenolic compounds, which are present within the respective ecosystem of this, or the natural habitat of these tyrosinases, are accepted as substrates and can therefore be removed. So now I want to give you a little future outlook, what's still planned and what's still left to do. So the next interesting question, of course, would be to see if hydrolytic enzymes, if the activities of hydrolytic enzymes will increase with increased tyrosinase activity as it's proposed to an elevated level of removal of phenolic compounds. Then, of course, we want to see in what way climate change can affect the production and activity of tyrosinases. And this will hopefully lead to the development of strategies and methods for controlling tyrosinase activity, since, as you know, that it's a very urgent matter to reduce CO2 emissions also from wetlands, which, as you have seen in the beginning, store really vast amounts of carbon and really globally significant amount of carbon. Yes, so ideally it will be possible to reduce CO2 emissions from wetland ecosystems. Okay, so finally, I want to thank the University of Vienna for funding my research and the Department of Biophysical Chemistry. I want to thank the FWF for funding the research. I want to thank you, Emma, and Scisynopsis for giving me the possibility to show you my results and for hosting this beautiful event. And I want to thank you for your attention. So thank you.
Thank you, Thank you, Dr. Felix, for your presentation. So, any questions from anyone? Okay, no questions, I think. Thank you once again, Dr. Felix, for your presence.
Thank you as well.
Thank you. So now we got the presentation of our first speaker, that is Dr. Sequin Fang. So I'm giving the access to Camille so that she can share the screen. And hello, Dr. Sequin, are you with us? Hello, Dr. Sequin. Dr. Sequin Fang. Okay, I think he is not active. So we'll move further for next presenter, that is Muhammad Umar Sahar. Yeah, hi, Dr. Sequin. Are you active?
Yes, yes, I'm active.
Okay, fine. Then I'm giving, so Miss Camille will share the screen. So whenever you need to change the slide, just let us know. She will change the slide for you.
Okay.
Okay. Okay, give me a moment. Let me check with Camille. Yes, you can start. You can start the presentation.
Okay. I'm sorry, everyone, professors and doctors. I'm sorry for the delay. And um, today I will share my presentation about the atomic dispersion of metal nanoparticles and their performance in methanol carbonation. Firstly, please allow me to introduce myself. I'm a teacher in the universities of Chinese Academy of Science. And next, and this is the map of China. And my institute is located in the northeast of China. Please.
自动拾取、自动挂机、自动回收的传奇，你玩过吗？这个版本是全新的。
Please next. And this is my institute. My institute was located in the Dalian city, Liaoning province, and next, it is the Dalian Institute of Chemical and Physics, Chinese Academy of Science. And next, So, and this is Dalian, which is located at the party, and this is our institute. It is very beautiful. Next, I'm working in this building. This is our environment, our report hall. Next, and this is our campus. Okay, this is my working conditions. We can prepare catalyst and uh, use it to many reactions, and then we can characterize it in with many equipment. Next, okay, this is our pilot test equipment. After test the activity of the catalyst, we will enlarge it in the pilot in the single tube to to verify its activity. Our main ideas is to commercialize the catalyst in industry. Next, please. Okay, this is our recently industrialization the in equipment. It is the 40,000 ton year of ethylene hydroformylation with a single atom catalyst. So please next. So I will share you my our academic ideas. We many curious about the social problems such as the energy and the CO or the hydrogen, and uh, our main our main research was concentrated on the basic research as well as and the industrialization. Next. So today I will share my the topic of my presentation about the atomic dispersion of nanoparticles and their correlation performance. Next. As you can see, the metal catalysis suffer from several steps, and there are many uh, concepts, and such as the Lala catalysis and the cluster catalysis, and in the recent decades, the single atom catalysis is very popular. And next. So my research interest was concerned about the single-site catalysis, about their presentation. Next, and their problems such as the mechanisms and their interactions between the metals and the environment. We mainly concentrated on the methylene carbonylation and the ethylene or acetylene carbonylation. Next. So firstly, I will introduce my our findings about the method to atomic dispersion of the nanoparticles. We use the CO and the methylene iodide. We can realize the atomic dispersion of transitional metal particles. As you can see, the rhodium nanoparticles could ultimately disperse to the single nuclear catalysis. And this method is very general and efficient, which we can use it to disperse the nanoparticles of rhodium, palladium, and iridium, and so on. Next. Next. So even though the iridium nanoparticles is very difficult because the iridium nanoparticles has a very strong bond metal and metal bond, but uh, we can also disperse it with CO and the iodide. Next. Next. So as you can see, we can, and this method is very general. It is can be applied for many nanoparticles. Next. Next. So how, but maybe someone would be curious about the application of this single atom catalyst. Uh, this reaction is carbonylation. We can use CO and methane to produce methyl acetic or methyl or acetic acid. And we're using the methyl acetic, we can hydrate it to produce ethylene, or we can further carbonylation to produce methane anhydride. Next. 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 And for the single atom catalyst iridium, it demonstrated efficient activity to this reaction. We can say its active or catalyst activity was very good. Next. Besides, we can use the automatic dispersion method. We can use it to disperse the nanoparticles, which was deactivated uh, from the agglomerated nanoparticles. So this is, we can adjust the conditions to produce the acetic acid or the methyl acetic. Next. Next. Moreover, we produce two kinds of catalysts. The single nuclear iridium catalyst or the dinuclear iridium lanthanum catalyst. With the dinuclear catalysts, which demonstrated very stable activity, and their activity is very is more beneficial. Next. So we have investigated the mechanism of these two catalysts and found that the single nuclear catalyst has a very high energy barrier in their last step. But however, for the dinuclear catalyst, the lanthanum atoms could reduce their energy barrier. Next. And the other topic we curious we are interested about the relationship of the homogeneous or heterogeneous catalysis. Uh, Generally, the homogeneous catalyst is more superior than the heterogeneous catalyst. However, where we have supported the homogeneous catalyst to the surface of activated carbon, the heterogeneous catalyst demonstrated almost 3 times activity than the homogeneous catalyst. And next, more in-depth investigation revealed that the oxygen functional groups on the surface of activated carbon is very important, which would devote more electron to the rhodium to the single atom catalyst and uh, kept it to get more efficient activity. Next. Next. Besides, we have many works about the acetylene with the atomic dispersion of palladium. We can produce a single site palladium catalysis. With this catalysis, we can realize the double carbonylation of acetylene. It is very important. Next. So we think about the problem about the homogeneous and heterogeneous catalysis. It was accepted that the single site catalysis linked and operated the homogeneous and heterogeneous catalysis. So maybe we can get some ideas or inspiration from the homogeneous catalysis. Next. So with adjusting the substrate with the water or methionine, we can realize the single carbonylation of acetylene to produce this product. Next. And we concentrate on their basic scientific problems about the rules about the metal ligand interactions and the correlation environment was very important to influence the performance of the single site catalysis. Next. The last interesting phenomena we found is about the sulfur-related chemistry about the single atom catalysis. As you know, the sulfur poison was very important, and it is still a challenge for the metal catalysis. However, uh, few people was concentrated on focused on the single atom catalysis. In this part, we found the single atom catalyst demonstrate sulfur promoted activity to methionine carbonylation. Next. Next, please. And this phenomena was very general, and we can see it in the reaction of ethylene carbonylation or acetylene carbonylation. Next. And there and other single atom catalysts also show some degrees sulfur tolerance. Next. We also investigate the phenomena with many techniques or in situ characterizations, and we can find that the hydrogen sulfur was transformed to the methionine to the methyl sulfur. Next, and many people maybe ask the question why the transformation of the hydrogen sulfur to the methane sulfur would benefit this reaction, and our research found that the hydrogen sulfur is real detrimental to the single atom catalyst. However, the transformation of the hydrogen sulfur to the methyl sulfur would benefit the single atom catalyst to get a lower energy barrier to promote the reaction. So the mechanism investigation is very important. Next, please. Besides, we also found a phenomena of sulfur poison to the single atom catalyst. However, this single atom catalyst could recover from sulfur poison. It is also very interesting. Next. This is our kinetics activity test. Next. And the mechanism investigation revealed that the hydrogen sulfur is also was very bad to stabilize the single atom catalyst, which has the lowest free energy. However, the other ligands such as the CO and the hydrogen could remove the sulfur from the single atom catalysis. So the single atom catalyst could be suffer from the poison. Next. I can finally, thanks very much for your attention. If you welcome you to visit our institute. Thank you very much. Is there any question about my topic or works? It doesn't matter. If you have any question, maybe we can communicate offline. I will share my email, or we can cooperation to produce some works. Thank
Thank you,
you.
Dr. Sequin, for your presentation.
Thank you very much.
Yes, so any questions from anyone?
Thank you again.
Okay, no questions then. Thank you once again for your presence and presentation. Okay, so move on to the next presenter is Dr. Muhammad Umar Sahel from Institute of Space Technology, Pakistan. And the title of the talk is Effect of Secondary Combustion on Thrust Regulation of Gas Generator Cycle Rocket Engine. Hello, Dr. Muhammad. Are you ready with your presentation? Yeah, can you please share your screen with us? You need to click on the share icon, that is
Yes,
the
thank you
third
so
one.
much. Let me share my presentation, please.
Yeah, you can share the presentation, but it's yes, it's loading.
Yes, yes,
Yeah, we can able to see. Again, it's gone.
sure. I just need 1 minute to share my presentation.
Okay.
Also, you
Yes,
can see
it
my
is
presentation
visible.
right now.
Yes, yes, yes,
Uh,
yes. Yeah,
Thank you.
perfect. Please continue.
Thank you. In the name of Almighty, the most beneficent and merciful, first, I would like to thank Ms. Morgan for inviting me in this prestigious international conference. I feel honored to join fraternity and family of such elite scholars, researchers, and professors. Before the start of my presentation, let me introduce myself. I am Dr. Mohammad Umar Sohail, currently serving as an assistant professor in Department of Aeronautics and Astronautics Engineering at Institute of Space Technology, Islamabad, Pakistan. Today I am presenting effect of secondary combustion on thrust regulation of gas generator cycle of rocket engine. Here is the sequence of my presentation that will include motivation of study, problem statement, some conceptual ideas, and then conceptual design, methodology, rocket propulsion, engine design, experimental work, and then conclusions. The liquid propulsion rocket engine are used in launch vehicles and long-range ballistic missiles because of its high delivered performance, reliability, and affordability. Major advantage of liquid rocket engines over other devices is wide range of variable thrust available to match the mission requirements. Its fast response time, altitude hold, and capability to test fire engine on ground base before the launch. The operation and performance of liquid rocket engine depends completely on combustion stability, propellant characteristics, and nozzle geometric parameters. So, designing a liquid rocket engine has always been a major design concern for a rocket designer, especially when it comes on deciding nozzle expansion ratio. The nozzle expansion ratio plays critical role when it comes to space launch vehicles and reusable launch vehicles. At high altitudes, all launch vehicles require higher nozzle expansion ratio to attain a higher specific impulse for minimum fuel consumptions. But during lift-off stage, launch vehicle requires low nozzle expansion ratio to avoid nozzle flow separation and to maintain a specific thrust to weight ratio. These two conditions cannot be applied together with a fixed nozzle expansion ratio. So here you can see the both underexpanded and overexpanded nozzles. We know when exit pressure is greater than atmospheric pressure, the nozzle is said to be underexpanded, as you can see over here. The exit pressure is smaller, greater than the ambient pressure. It reserves the gases at pressure greater than atmospheric pressure. But when the exit pressure becomes lower than atmospheric pressure, the nozzle is said to be overexpanded. As a result, flow separation occurs as if high pressure pushes the exhaust flow inward, reducing thrust and creating negative pressure gradients. One way to overcome the conflict, as discussed in previous slide, is to make a multiple staging of liquid launch vehicles to reach the desired altitude, which will exponentially increase the operational cost. So the first concept, as you can see over here, cannot be tested due to the limitations. As you can see, the limitations, unavailability and unattainability of integrated wind tunnel in Pakistan, in which combustion can be conducted at desired flow conditions. So the first concept we cannot fulfill, we followed the second concept. Here is the second concept in which both kerosene and liquid oxygen, that is considered as LOX, can be used as an oxidizer, but it had some limitations as mentioned here. Requirement of high volume compressed LOX and air cylinders. These were the limited stock over here in Pakistan. Material limitations, oxidizer, which primary combustion would generate high temperature. So these two ideas cannot be fulfilled, so we have to come out from the other way. So the other way was to another way to reach a desired altitude is to use single stage integrated with 10, that is a thrust augmented nozzle. This will not only increase the overall performance but will also reduce the operational cost. So the idea what we got from the 10 is from F-16 aircraft. The aim of the research was to focus on expanding the tank combustion modeling and establishing a testing capability for exploring and evaluation of tank design. So we got an idea to conduct burning in diverging section of CD nozzle like F-16 afterburner. This concept was not yet been implemented on space launch vehicles and reusable launch vehicles. So here we have conducted a supersonic combustion inside the CD nozzle by injecting oxidizer in diverging section of the CD nozzle. So the injection of oxidizer in the CD nozzle was the main part of this research so that the performance of the system can be improved. A lot of research has been conducted on TAN by Aerojet Rocketdyne. So thrust-augmented nozzle is also called a rocket afterburner as a principle of operation of TAN in the launch vehicle is similar to that of the afterburner in the fighter jets. In a fighter jet, afterburners are utilized during takeoff for supersonic cruise and for performing high G-comfort maneuvers. Whereas in launch vehicles, afterburner concept can be applied to re-energize the jet flow in nozzle to avoid flow separations, obtain a high thrust to weight ratio, and to keep the nozzle optimized throughout the mission, even in vacuum state. Here you can see our rocket engine design, keeping in mind the supporting hardware available in our institute, University Institute of Space Technology Propulsion Lab that was being established for the conduction of this research. It was decided to keep the size and scale of the liquid propellant rocket engine small, keeping the thrust in between 100 Newton to 150 Newton. To begin with, few assumptions were made. The liquid propellant rocket engine were assumed to be ideal and the exhaust gases were assumed to be isentropic, which meant that the pressure and heat losses are at minimum and propulsive efficiency is at maximum. Here you can see the design parameter of our rocket engines, design parameter of our nozzles, and the primary combustion species. The flow separation that was being conducted through CFD analysis, the flow separation point, that's the distance in the axial direction, was estimated empirically using Carl and Budel Schumacher flow separation criteria which was about 37 millimeter after the throat. To validate the flow separation point, a primary flow simulation of combusted species of rocket propulsion and LOX was carried out without modeling combustion at sea level conditions. It is seen that the flow after passing through the throat expanded and detached from the wall of the nozzle, exactly at the location estimated using the flow separation criteria. This simulation also revealed a complicated shock formation, which was due to the flow adjustment to ambient pressure. The adverse pressure gradient caused a shock wave inside the nozzle, which separated the mainstream flow and boundary layer from the nozzle wall. Due to our expansion and our compression, a repeated diamond shock and triple point and incident shock, a marked disk, and a reflected shock were also observed, as you can see in this figure. So, results obtained from the combination of injection velocity. Here we are using three injectors and all the injectors are combined and we are injecting the rocket propellant inside the combustion of the combustors. So the result obtained from the combination of injection velocity, injection angle, theta, and injection position, x, SI denoted by, are presented in these slides. You can see the baseline. Baseline is the line without the tan in operation. Injection angle, injection position, and injection velocity. Here we are using some symbol that is 30 SI 100. So it means the 30 SI means the injection angle is conducted at 30 degrees, injection position is kept at 20 millimeters downstream of the throat, and injection velocity is 100 meter per second. You can see that all injection angles and locations of gaseous oxidizer injected at 30 meter per second absolutely energizes the exhaust flow to make the flow supersonic, while injection velocity of 100 meter per second and 200 meter per second is not sufficient to make the exit Mach number supersonic. So in the next slide, we are using the second injector having the same phenomena as discussed in the previous slide, that was the first injector. In the same way, you can see the third injector phenomena. All these injectors show that injection angle and locations. Gaseous oxidizer are injected at 300 meter per second, absolutely energizes the exhaust flow to make the flow supersonic, while injection velocity of 100 meter per second and 200 meter per second was not sufficient to make the exit Mach number supersonic. Now, here you can see the injection techniques. These are our normal injectors. So these are the three injectors which we are using. So now over here, it can be seen that injection of gaseous oxidizer normally at 300 meter per second having a mass flow rate of 0.012 kilogram per second before flow separation point gave stable flame and strong combustion mood with temperature ranging from 1500 Kelvin to 2500 Kelvin. The increase of gaseous oxidizer mass flow rate was able to penetrate and mix with the core flow more efficiently, while the symmetry of the flow was also maintained. Now, these are our experimental work schematic diagrams. You can see we have used pressure bottles, LOX tanks, solenoid valves, flow meters, emergency stop. In case of emergency, we can stop it. Pressure sensors, injectors. We have used three injectors: liquid propellant rocket engine and 10 thrust augmented nozzles, fuel inlet, fuel tank, gaseous oxidizer secondary supply, and pressure reducer valves. So this was the experimental work setup, which was being set up in our Institute of Space Technology, Islamabad, Pakistan, in rocket propellant lab. You can see over here, these are the Grox flight line, pressure gauges, and gaseous oxidizer manifold. These are the experimental work propellant supply lines. And now over here, you can see the figure shows the exhaust plume before the initiation of secondary injections. So over here, secondary injection has not yet been initiated, and you can see the plume of exhaust. The plume before the secondary injection of COX stands for gaseous oxidizer, was small and unstable. That shows that the flow was separated from the nozzle wall due to large nozzle expansion ratio. Now, the flow inside the nozzle re-energized and gained some momentum following the start of secondary injection of gaseous oxidizer. Injection of gaseous oxidizer inside the divergent section of the nozzle before the flow separation point caused gaseous oxidizer to mix successfully with the fuel-rich flow, causing combustion inside the nozzle. Moreover, due to secondary combustion, the flow accelerated and the fume became turbulent. As you can see, the flow is now turbulent. This is caused due to the secondary combustion. The flow accelerated and the fume becomes turbulent. Now remember over here, the flow is called to be turbulent, but yet secondary oxidizer was not yet been injected. Now when it comes to secondary oxidizer, you can see over here the result shows that after secondary injections, combustion in TAN is now stabilized. Now, over here, the result shows the combustion pressure measured against time for 15 seconds without secondary combustion. So up to 15 seconds, there was no secondary combustion. So it was noted that a combustion pressure of 2 bar was maintained from 5 seconds to 12 seconds, confirming consistency and reliability. Over here, you can see the result shows the secondary combustion temperature in which secondary injection was initiated. The burn time duration of the test was 35 seconds, which was kept longer to establish the flow in the nozzle and sustain secondary combustion to stabilize the combustion. It can be seen that temperature rose gradually from 0 seconds to 15 seconds. This gradual rise was because of gaseous oxidizer injection effect and slow settling time in the nozzle. The injection temperature of gaseous oxidizer was 300 Kelvin, as we have discussed in the previous slide, and there was only a possible of gaseous oxidizer making a boundary layer over the region where the thermocouple was axially placed. After 15 seconds, the temperature inside the nozzle increased abruptly, indicating settled flow and sustained combustion. So the chemical reaction which we have used in this project, the product obtained from reacting blocks and uh, propellant are used as reactants for secondary combustion reaction, and the final product species were obtained. The composition of different species at equilibrium are determined by minimizing the Gibbs free energy of the system. For minimizing has been done using a method of steepest descent, and results obtained were refined by Nelder-Means method. So the mass fraction of these species were compared with the mass fraction, and chemical equilibrium calculations were validated accordingly. These species of the secondary combustion we obtain from the CFD analysis. This is the Gibbs free energy system which we have used over here. To achieve equilibrium, the Gibbs free energy function is minimized in the reactions, and you can see the Gibbs formula where the subscript and we have used some mu and I, n, where n is the number of moles of the given species, b is the moles of element, and mu I is the chemical potential, whereas the beta which we have used is the coefficient matrix. In the coefficient matrix, we have used different propellants such as uh, hydrogen, carbon, and others. Over here, you can see the mass fraction in combustion species obtained from CFD along the axial length of uh, divergent sections. These species are the product of secondary combustion with the gaseous oxidizer. So, the preheated primary combustion product react with gaseous oxygen to produce these species. So you can see the many species we have used, such as carbon, methane, carbon monoxide, carbon dioxide, hydrogen, and somewhere is water as well. So by conducting these experiments and even with the CFD analysis, we have just concluded some of our results, performance estimations. The performance of the rocket engine and the nozzle is dependent on parameters such as thrust, specific impulse, thrust specific fuel consumption, thermal efficiency, propulsive efficiency, and overall efficiency. So you can see these two figures. The figure shows the strength of thrust and a specific impulse of configuration of C1 and the baseline configuration. The baseline configuration is what we when the 10 was not being initiated. It was observed that about 42% of thrust increment and 46% of specific impulse increment were achieved at sea level. So the thrust and the specific impulse were enhanced ranging from centerline 0 to 21 millimeters. So what we have concluded from the experimental setup by introducing a 10 in our converging diverging nozzle of the rocket engine that was not yet been uh, researched earlier, and we got the idea from the F-16 afterburner. We got a conclusion. It was observed that the tank performance is great when COX is initiated, normally at 90 degree at 20 millimeter of the throat with injection velocity of 300 meter per second. And before the 300 meter per second, we have conducted 100 meter per second and 200 meter per second through computational analysis. We got the result that the flow is not going to be supersonic. So after the 300 meter per second of injection velocity, the flow becomes the supersonic. So in 3D CFD simulations, a total of 8 cases of gaseous oxidation injection were studied. The computational data revealed that in practice the normal injection technique exceeds the tangential techniques. The effect of normal injection revealed that the injected place closer to the throat generates sustained flame and combustion since more length is available for mixing the burning of species. So, gaseous oxidizer mass flow rate also has an effect on combustion temperature. The more mass flow rate, the higher the temperature and stronger the combustion flame. Same way, a strong combustion flame inside the secondary combustion zone reduces the expansion ratio and energizes the flow. Stronger combustion displaces the exhaust jet towards the center line, reduces the expansion ratio. That causes the jet to streamline and accelerate furiously. Thus, an increase in exit Mach number is achieved. It was also found that the high propulsive efficiency can still achieve with low effective exhaust velocity. was also demonstrated that primary combustion chamber pressure has an effect on the burning inside of thrust augmented nozzle. By lowering the primary combustion chamber pressure, species mixing, reaction and burning can be enhanced inside the tank. So, the low combustion chamber pressure provides time for species to react and burn significantly. It was also found that the high propulsive efficiency can still be achieved with low effective exhaust velocity, which means more fuel economy. Nozzle length played a vital role in mixing a complete burning of species. Since the exhaust flow is supersonic, therefore less time is available for propellant to mix, decompose, and burn. Whereas we are conducting some future work as well. So the future work that can be conducted on this existing project, based on normal and tangential secondary injection techniques, must be investigated in combustion, and right now we are going to work on it. TAN must also be explored by varying primary oxidizing fuel through throttling. More testing of the fuel which TAN using a longer nozzle is recommended. We can see the future applications. In TBC, we are using the thrust augmented nozzles, optimized nozzles, cruise mission profiles, and propulsions, and thrust augmentations. So thank you so much, so nice of you for hearing me. Over to you. Any question, please?
Thank, thank you, Dr. Muhammad, for your presentation.
Welcome.
So, any questions?
I think there is no question. Thank you so much for
Okay,
your
no
time.
question. Thank you once again for
Thank
your
you so much.
presence and presentation.
Thank you so much. So nice of you.
Okay, so we will move to the next presenter. That is Prem Kumar Jaiswal from retired. He's a retired director of labs from India, and the title of the talk is National Food Control System in India. Hello, Dr. Prem Kumar.
Good afternoon to everybody. I am
Yes, I'm
yes.
going to make you the presenter. Just a minute.
Oh,
Yes, can you please share your screen?
okay. Is it okay now?
Just a minute. No, it's not.
Hmm?
Still not visible. No.
Is it okay? Hello.
No, no, it's not visible.
Acha, it's not visible. Just a minute.
Yeah, you need to share whole window.
Acha, okay. Just a minute.
Okay.
Just a minute. Okay. Is it visible now? Hello.
No, no, it's not
No.
visible. No.
Acha, I have to just Wait a
Okay, is it a
minute.
MacBook?
No, no. Is it a regular laptop?
Okay, then it should not be a problem then. You need to
Just
click on the share icon. So what is showing after that?
share icon. I am not able to see. That is the problem.
Yeah, you can see that the third one, third icon on your
But it is
system.
not visible here. It is not visible here. Just, just a minute. I'll close this.
Okay.
Share has not been connected to me. Hello.
Yes, yes, I'm going to give you another time.
Okay.
Just a minute.
Okay.
Yes, can you try now?
Yes. Now this is there.
Okay. Yes, now we can able to see your screen.
This is again not visible, na?
No, no, it's opening. It's visible. Yeah, now we can
Visible.
able to see. You can make it a full screen and start
Yeah, it
presenting.
is full screen. Okay. Now it is okay.
Yeah, perfect.
Thank you very much. So, thanks to the organizer for giving me an opportunity to make a presentation on National Food Control System in India. Uh, you are well aware that now there is a tremendous progress and international marketing and business of the food between the different countries due to the WTO agreement and FAO involvement, WHO involvement, and Codex Alimentarius Commission involvement. So this is the content of my presentation: National Food Control System introduction, scope of National Food Control System, objective of National Food Control System, scope, principle, responsibility, component, food chain, system design, implementation, monitoring, and system review, and NFCL in India, strengthening activities, and conclusion. So, food control as defined by the Food and Agriculture Organization, that is all mandatory activities necessary to assure the quality and safety of the food. So then it is the question that how one can assure the quality and safety of the food and make it a implementable food control system. So so there are basically four structure of this, that there has to be food law and accompanying regulation for that particular food law. But you know that the food commodities in enormous, so there are so many food commodities which have not yet been standardized in India, so they are being taken as a proprietary food. So there is a common horizontal standard applicable to that, such as pesticide, metal contamination, pesticide, aflatoxin, and biological contamination. So there has to be a food inspectorate. So this is to be at a federal and a state level both. Then what is the next is more important, that analytical services and compliances unit. Analytical services and compliances unit, there has to be some food, a number of food laboratories. You see, earlier, about 12 years ago, there were only the government food laboratories which were engaged in the uh, testing protocol of the legal sample, surveillance sample, and other type of the samples. But due to the inadequacies of the government laboratories, the government decided to approve the NABL accredited laboratories working as a private laboratory throughout the countries, so that there is no delay in the testing of the food commodity. Then as a supporting services has to be there, that is education, information, training, and advisory support. You know very well that the education is very important, consumer awareness is very important, providing proper information of the food on the label is very important. Then training to the uh, uh, food controller or food inspectors are very important, including the laboratory staff. Regular activity by the national, state, or local authorities provide food quality and safety protection to ensure that that foods during farming. So this is what, in this particular case, there has to be entire food safety quality management system in the entire food chain. Not that we are going in for testing of the finished product and then evaluating the quality of the product, because ultimately if the quality in any of the food chain is deteriorated, the product is going to be deteriorated and making it unsafe. So that is very important, that the government has taken proper care to ensure that all the food handler or food business operators, in excluding farmer, are issued a food licenses for the commodities for which they are competent to do so. Now we can ask a question, that why the farmer has not been included under the food control system. In this particular, special privilege has been given to the farmer to avoid all these issues of the regulations, because they are the marginal farmers, and most of the cases they are marginal farmers, and more than 73% farmers are marginal farmers. So it is not possible for them to go in for the food regulation and this. But ultimately, on the other side, now a contract system has been adapted between the manufacturer and the farmer, so that the manufacturers take due care of the product which is being grown by the farmer, that it is a safe food. So this is how the safety is being maintained at the farmers level. Now, public confidence in the food regulation mainly depends upon established evidence that there is a low and acceptable level of this. This is very important. Until ultimately, consumer is the most important person in the food control system, and uh, it is the prime duty of the government to provide a safe food to a consumer. So how to do that? So in such particular case, the in India, the authorities have involved the private persons, industry person, consumer organization, and scientists, professors, and so many other persons in the form of a food authority, to ensure that uh, a proper good decision is taken, ultimately with the objective that a safe food is served to a consumer, and assurance to have a scientific system to monitor, analyze, control food. How this is done? That there has to be, there is at the state level and at the central level. I have already told that there is a system of licensing. Number one, that uh, food business operator can only manufacture a food for which he has been given the license. And in this particular case, so food control systems have to be properly carried with the risk assessment data. You know, the Indian Standards and Food Safety Authority implement that a science-based data should be produced so that to establish the food standards, and the data is communicated to the consumer also through a notification, and the other control system are also being restructured. SPS now sanitary and phytosanitary agreement technical measures are allowed only when scientifically justified, establish the risk-based food control system in compliance with the trading requirement. You know very well that the international business in the food has increased manifold, and for this year there has to be proper agreement that any food which is being exported to advanced countries or any food in India which is being imported in India must meet this SPS agreement requirement, and there has to be a mutual understanding of the standards acceptable to the both the laboratories, sorry, to the both the countries. And then after that, a testing protocol. Now the government, in a number of cases, the government is approving the uh, internationally accredited food laboratory to accept the report while they are while exporting their samples. The objective of a national food control system is to protect food safety for the consumer. Ultimate objective to ensure fair practices in food trade in context of food quality and safety. What is this? To ensure a fair trade practices. Suppose in my country, the limits of the pesticide residue in any agriculture produce is quite safe, whereas the limit of pesticide residue in other country is much lower. And the problem is that because India cannot go below the production of that particular safe level of the food, but this has to be ensured in the internationally transaction of the food that those food standards are acceptable by both the countries through some mutual understanding and agreement. Now, food control system include uh, food produce except direct implementation at farmer level. This is I have already told that the farmers have been exempted from this direct farmer. But suppose any middleman is coming through that, then in that particular case, uh, it is the responsibility of the middleman to have a food license. So this exemption has been given only to the farmer who is really a farmer. So such systems are statutory and mandatory and regulatory in nature. There is a system that these are the principle of the national food control system that first objective is the protection of consumer, and the and next is food chain approach. This I have already discussed that the food chain approach is a must to ensure that finally any food reaches the consumer as a safe food. Now in this food chain control, there is a farmer, storage, harvesting, transportation, primary person for storage, then manufacturer, then distributor, retailer, and so many. Mean the entire person can be there, and there has to be a transparency. What transparency here meaning that there has to be a traceability of the food item. That suppose in any case the food goes unsafe, then it should be easily accessible to the regulatory authority and to the food manufacturer as well, that he could trace out the that particular food from the market and get it withdrawn. Now roles and responsibility of the it, obviously the roles and responsibility of the RD dignitaries have to be defined. There is a licensing officer, there are food safety officers, there are technical officers, there are food analysts, and so on. Consistency and impartiality. So consistency and impartiality is a very important aspect. Now, incorporation of risk, science, evidence based, and decision based approach. This I have already discussed that the food standard have to be science based food standard, and any decision, any formation of new regulation, rules, and act are being taken as per procedure involving all the persons. Uniform implementation by multiple competent authorities as state at central level. So this we have already preventive measures. Preventive measures. How can we get a preventive measures to ensure that a safe food is in the market and no adulterated or unsafe food are being sold. So there is a system of surveillance by the government. Regularly, they are carrying out the surveillance of most adulteration or unsafe prone food, and then getting the data and taking preventive action to ensure that those things are minimized. Self-assessment and review procedure, recognition of other related system involved in the food control system. You see, in India, there has been so many other voluntary organization like EGMARC and BIS. They are also involved in the food safety quality assurance system, but those food safety standards are voluntary in nature. It is just for the consumer to ensure that a third party certification is there for every batch of the food being prepared. But the most sensitive food item like packaged drinking water and then blended oil and so on, they have been put under compulsory certification system by the government. Legal foundation is a must. So there is a some full-fledged legal legally competent personnel available so that they can go to the court, find their cases in a presentable manner, and succeed in the interest of the consumer. Harmonization of standard and regulation to possible extent. Now, this is harmonization of standards. Uh, this is well aware that now the Codex Alimentarius standard has been taken as a internationally accepted standard for all the countries to ensure that they are able to standardize their product to a maximum, to a possible extent of harmonization with that of the codex standard. But in certain cases, if due to the, any scientifically based reason it is not possible to harmonize the standard, then they have to go in for possible extent uh, to to harmonize the standard. But above all, they have to ensure that the food is safe and good for human consumption. Resources and technical competency. This technical competency and resources is a must. Now, legal reduction through principle of prevention and control through entire food chain. So there is a system of inspection, surprise inspection, proper checking, surveillance, and so on to ensure that as far as possible in the entire food control system, a safe food is provided. Protection from significant hazard throughout the entire food chain. This is a must that there has to be some protection. Now, enforcement of food laws for consumer protection and establishing food alerts like food recall system. So this is especially in case of the food food which is imported in the country. In case it is found that there is some problem of safety of the food, so either that particular commodity is being banned from importing into a country, and there and red alert is made. Active participation and cooperation of all stakeholders. This is that in all the decision making uh, point, all the issue participant and the stakeholder have to be taken into confidence. The public are given a chance to submit their view through a notification made public through the website and Gazette of the India. A food safety is a shared responsibility. Now how why we have used the word shared responsibility, because ultimately there are so many agencies which are not direct uh, controlling the food safety, but they are indirectly involved in the system, such as packaging material is, is there, and so many other, and so this has to be ensured that the even any item, chemicals or other thing which is being used as a food additive, it must be of food grade, although food licensing is not required for them. Similar in the case of packaging material, that it has to be of food grade, and ink which is being used for the purpose of printing should be of food grade also. And ultimately it is basically the consumer responsibility. Consumer has to give a feedback how this is going on, what is the his feedback, how the government can act more rigorously on the to minimize the unsafe food in the country. Now, shared responsibility involves two is there, three. One is government. What is the shared responsibility of the government? That it is food legislation and enforcement. This is very advice for industry and trade. So many advisories are being issued by the government also. Consumer education is a must. So consumer education, there has to be some program, awareness program in colleges, schools, through some mela and through some exhibition, that the consumers are educated. Information gathering and research. So many research institutions have been associated with uh, the food control authorities to uh, give a good food feedback of the data for the purpose of formulation of the food standard. Provision of the health related services. The health related services means suppose some food poisoning has taken place and some other serious matters has been made, then the government has to take a special care for that. Now, what is the responsibility of the consumer? Educated and knowledgeable public. So we have to teach each and every public that the food being purchased by him from this should be from a reputed shop, licensed shop, should contain all the label declaration and other thing. Discrimination and selective consumer. So this we have to see that we have to select a particular group of the consumer through consumer association. They are representing with the government uh, body to provide the consumer views. Safe food practices in the home. This is very important, that above all we have to follow the safe food practices in the home. That suppose any food is kept in the fridge at 3 to 4 degrees centigrade, we are taking out that particular food, keeping it for a long time outside in the kitchen, then again putting the uh, remnant of the food. Those good practices, kitchen platform has to be very neat and clean. Like that, I think everybody knows about it. That the safe practices has to be followed, and above all, the best before use must be seen in the item, which has to be retained in the fridge or in the deep freezer at minus 18 degrees centigrade. That whether the best before has not expired. Community participation is a must. Active consumer group through some association and other thing. Good practices by primary producers and distributor. These primary producers has these primary producers have to follow a good agriculture practices, and for the post harvest properly good practices to get a safe food grain or fruits or other thing which are the primary food at that level. Quality assurance and control of the processed food. This is the responsibility of the industry to ensure that the food which is getting such as raw material, each batch is properly tested, proper records are maintained for that, and then they are keeping a analysis and data of their particular food. Appropriate processes and technology. This is very important, that the processing must produce a safe food, that there is no metallic contamination, no plastic contamination in the finished product. Trained manager and food handler. It is a must that the managers are trained and the food handlers are they are medically being uh, tested every year. Informative labeling and consumer education. This is also very important than that any food, what is inside it, must give all the information of labeling. And now this is a food chain. We have already distribution discussed that how the food goes from a farmer, transporter, miller. This is a food chain, how it reaches the final plate. Now, framework of the national food control system, policy setting, system design, implementation, monitoring, and system review. Continuous improvement is a must ultimately, because no system is perfect, and we cannot get the 100% safe food in all the cases. So there has to be a reason for continuous. This is through you know, a certain system like HACCP, ISO 22000. So many food safety management systems are there. Define goals and objective of the national food control with expected outcome. Legislation should reflect the policy objective, which focuses preventive, allow acceptable innovation, clarity, define roles and responsibility of the regulator. You see, there is a website of Food Safety Authority of India in which all the details have been given to you, that even as a consumer, as a food business operator, as a inspector, all the details, roles and responsibility have been given in that uh, website. Require all concerned to establish and monitor appropriate control at all stages: food chain, reduction, production, transportation, distribution, and trade. Clearly defined obligation on FBO to produce safe food. So far, the regular inspections are done, online inspections are done, surprise inspections are also done. Consider recognition of and other harmonization with the codex keeping in interest. This we have already discussed, that the harmonization with the codex standard is a must to a possible extent. Include provision for the registration license penalties, punishment, and compensation in the event of non-compliance. So in case of the unsafe food, there is a criminal offense also, and the provision of minimum 3 months imprisonment up to the life imprisonment, depending upon the nature of the unsafe food which is being sold in the country. Competent authority to ensure safe use of food additive pesticide. This has to be in most of the cases. These national standards have been formulated, and so many new standards are being formulated to for food additive, pesticide, veterinary drug, in to enforce legislation and take action in case of unsafe. So they have to take the action, regulatory action, to ensure that unsafe food are withdrawn from the market and disposed of. So they have to be disposed of in a properly environmental friendly atmosphere, so that there is no chance of any pollution. FBOs and other participants to establish, monitor, appropriate control at all the stage of farming chain includes production, manufacturer. This obligation on food business operator to produce safe food. Ultimately, it is the responsibility of the food business operator to ensure safe food. Design of the national food control system. This is the design that existing regulatory and legislation framework, development, implementation of the food approach based system, risk management, use surveillance and monitoring program to target priority risk. Then design and implementation of a national food control should match with the available resources with the room of expansion. This is very important. There should always be a room for changes, making amendments. So regular amendments in the food laws are also being made through advisory regulation, depending upon the experience which are being gained due to the unsafe food being sold in the market. Then how to ensure that the ultimately consumer get a safe food. So Documentation to ensure transparency, reliability of the application of control measure, including description of its scope and operation, have a clear description of the roles and responsibility are involved. This we have discussed already, that encourage preventative food safety measures such as GAP, good agriculture practices, good manufacturing practices, good hygiene practice, hazard analysis, critical control principle, ISO 22000 food safety management system. These have to be means followed indirectly. Now it is not compulsory except in few cases, uh, that but there should be a basic fundamental system in place. It is not necessary that any food industry should compulsorily be ISO 22000 certified or ISO certified, but that is always better. Control program include inspection, verification, and audit. Verification, inspection, these are the system. Then market surveillance, some sampling and analysis, examination of record, documentation of observation and of findings, that examination of results of any verification system. By doing this regular survey and inspection of and taking samples for the legal sampling, their results are also being analyzed to see that what is the trend of unsafe food and adulteration being sold in the uh, uh, country. Compliance and enforcement program provide the competent authority to take corrective action where FBOs are not meeting their obligation or product processing, and put in place preventive action. What is there the system? Suppose we have observed any non-conformity or unsafe food being produced and notice is being issued to them. Yeah, giving him an opportunity to improve upon his system. If the improvement is done, re-inspection is done, then that notice is closed. Otherwise, his license are suspended and terminated. And in India, no food business operator can do the business of the food without having a proper food license. Resources allocation made in framework of a NFCS based on training and basic infrastructure, competent personnel of relevant disciplinary background, reliable transportation system, equipment, audit, verification, sample to the laboratory, information, um, communication, and the technology. There is a system that software has been developed, which are taking uh, the care of the uh, analysis of the all the sample, analyzing the data and giving the trend in the system, that what is the level of adulteration or unsafe food. In order to promote consumer confidence in food safety, to ensure fair practices in food trade, communicate all aspects of the dish for which they are responsible, including development, implementation. There is a system of the complaint, attending the complaint, that in case any uh, a complaint is received from any consumer or any organization, the food safety officer goes, find out the fact, inspect the premises, if necessary, take the legal samples also, and then further step is taken, says sending it for analysis and other thing. Now this recall system, food recall system, there has to be a coordinated approach between the regulatory authorities and the food business operator. Food business operator is expected to fully cooperate with the regulatory authority in ensuring that there is no unsafe food in the market. The competent authority have a roadmap to implementation series have a rollout different. Now the competent authority roadmap include what is the priorities and time frame for implementation, deliveries, responsibility for implementation, allocation of resources for personnel and infrastructure, training and operation manual. There are so many training and operation manuals are there, and if there is a regular system of giving training to the uh, food safety officer, licensing officer, so that their knowledge is kept up to date. Now, guidance and instruction relating to NFCA, regulator and FBO to ensure that all are fully aware what is expected from them. This is very important that food business operator and the regulator. So there are so many system prevailing in this. There is a case of scientific panel, scientific committee, other food authority in which private persons are also representing. So ultimately, whatever decision and regulation comes out of this is a combined effort of everyone. Now, implementation include inspection, audit, verification. This we have told earlier also. Now, rapid alert system are designed to implement for this purpose. Industry should be encouraged to develop training and to assess training and education program relevant to the activities and responsibility. When the competent authority intend to use the third party, now we in India, there is a system of third party certification approval system, and so many private agencies have been approved and recognized so that they can also carry out the inspection on behalf of the government and submit a report to them. This is just to strengthen because the regulator cannot have so many food safety officers, being India is a very big country, to implement it properly at each city. So, utilize laboratory that we have discussed already, that the technical competency, the laboratory has to be NABL accredited. Now, all the laboratories are food laboratories, whether of government or private, has to be NABL accredited, having technical competency, and then only it is approved by the food safety officer. There is a system of integrated inspection by the food safety officers persons and the NABL authorities also. Now, participation in a bilateral exchange with relevant competing authorities, trading partner, and international organization relating to food safety. Communicate and collaborate with international organization with food involving incidents, outbreak of. This is very important aspect. Sometimes there are food poisoning due to consumption of this spurious alcohol. Sometimes food poisoning in midday meal and the other meal are the food which is being served to the children. The government is taking due care of that. Then and uh, this is a session of review that we have, I think, limited time, to just I'll cut short. The review of the food related non-compliance can be used as a feedback for improvement by the competent authority. This is always there that every data is being analyzed. Then competent authorities should periodically review surveillance system with respect to their capacity and identify emergencies. Monitoring system review is there, utilize this. Foodborne illnesses and outbreak information should be used to inform the risk analysis. This this is result of the evaluation is used for further corrective and preventive action. Review for improvement is communicated effectively amongst all the stakeholders. Assessment of the control program should include issues such as effective control procedure, suitability if program has covered relevant stages in consideration of the emerging trend in the unsafe food and other things. This is the Food Safety Authority of a Act, Food Safety and Standard Act rules regulation. I have already told that there is a system and all the details have been given on the website also, everything. So if anyone is interested, he can go through that also. Promote use of preventive food safety strategy. Provision are based on scientific advances, labeling, and other regulation. Now, this is the legislation guideline, licensing, food safety standard act, licensing, registration, this novel food are there, labeling, codex standard. So this is how the food safety authority of in India is doing the work under this act. Food safety is an integrated national food control agencies. So food safety authority prescribes science-based standard. This we have already told that all the standards are made through scientific panel, scientific committee, and other thing also. Operate national food control programs. This is regularly then carries out risk analysis is done through regular sampling and other thing. Implementing agency inspect premises, processes for compliance with hygiene and other requirements of the regulation, evaluating HACCP plan and their implementation, identify food unfit for human consumption or food which is otherwise deceptive. Approving the third party certification, we have already told you that the training, awareness, and exhibition is a must. So this is the laboratory, a consumer like the this is a map of the laboratory services for consumer research development, import, market inspection, and sampling food manufacturer. FSSAI is continuously strengthening. Now we are coming to a conclusion that food safety ultimately is a shared responsibility of the government and all parties involved in the food chain, including primary production, handling, storage, this, and the consumer. Consumer need to be made aware. Ultimately, it is the consumer. Suppose I am a consumer, I should be well aware that while purchasing any food, one should be very careful to ensure to see few regulatory aspects like the date likely to expire now due to increase in online trading of the food also, which is tremendous in our country. The consumer had to take a proper precaution of that. Activity, demarcation of food control between this and central regulator, role of private agencies, this. So thank you very much for this. So thank you.
Yeah, thank you for your presentation. So, any
Any
questions?
question, I shall welcome it. So I think there are no questions. Okay, thank you very much. To I am again thankful to the organization for giving me an opportunity to express my views. Thanks a lot.
Okay, thank you for your presence and presentation.
Okay, thank you.
So perfect. So we'll move to the next presenter. That is, we have Laborde Stevenson Natchery from Institute for Basic Sciences, Technology and Innovation from Kenya. And the title of the talk is Transcript Expression Level Analysis of Phytoin Synthase and Phytoin Desaturase associated with beta carotene content and genetic transformability in beta melon. Hello, Dr. Laborde. Are you ready with your
Hello,
presentation?
Britain.
Yeah,
Yes,
hi.
I'm ready. Can you hear me?
Yes, yes. So I'm going to make you the
Yeah, allow
presenter.
me, allow.
Yes,
Okay,
yes.
thank you. Allow me
So
to
please
share my
click on the
screen.
share icon.
Mhm.
Yes, we can able to
Thank
see your
you.
screen.
Okay,
You can
fine.
make it a full screen.
Mhm. Is it okay now?
Yes, perfect. Please continue.
Thank you very much. My name is Dr. Labode Ospice Stevenson Nanchide. My presentation topic is a transcript expression level analysis of a phytoin synthase and phytoin desaturase associated with beta carotene content in selected Kenya beta melon. The outline of my presentation is here. About the background, let us say that the genus beta melon is neglected plant worldwide in various parts of the world. The fruits, the leaf, and the stem are used as food material. while the entire plant is commonly used as resources for pharmaceutical material. The leaf, stem, and roots and fruits of that plant contain beta carotene, the precursor of vitamin A in the human body. As we know, the vitamin A is necessary for the growth and the development of human body, as its deficiency is a severe problem that leads to the malnutrition, particularly in developing countries. In Africa, for instance, the local bitter melon species are near extinction because they have been replaced by the commercial cultivated plants. Uh, we know that the contents, the level of transcription in various carotenoid biosynthesis genes tell such phytoin center and phytoin desaturase affect the content of beta carotene. The production of phytoin is the first step or the initial step of the biosynthesis of carotenoids. Then the phytoin synthase enzyme produces phytoin via condensation of GGPP molecules, desaturation and isomerization of carotenoids of the GGP converts phytoin into to girardin, and then this way is split into two pathway. The first one is lead to the production of alpha carotene, and the second to the production of beta carotene. That's a way that pathway lead to the production of zeaxanthin and the anthraxanthin. We know that the vitamin A deficiency in the world is thought to kill about 700,000 children under 5 and 7.2 million pregnant women have vitamin A deficiency each year among the rural population. Therefore, a step has been taken to treat this deficiency through pharmaceutical supplementations. The alternative strategy found is to select and produce medicinal and food crop expressing high beta carotene content and other metabolites. However, when it comes to mass multiplication, the thick seed coat and the high seed coat break down the rates of the germination and lead to poor production of beta melon. To date, there is no enough characterization in terms of metabolites such as beta carotene in African beta amyloid. Moreover, there is no tissue culture or propagation of beta melon in terms of crop improving in Africa. However, selecting beta melon accession with high level of beta carotene will be of great value because of its agronomic, medicinal, and economical significance. And this will lead to industrial value addition and trade of beta melon in Africa. In addition, establishing correlation between PSY and PDS expression and beta carotene level in beta melon will allow for genetic transformation to improve its agronomic significance. Then the successful culture will lead to potential mass propagation of beta melon, and successful genetic transformation will lead to potential increasing of beta carotene level. The main purpose of this objective is the transcript, as I say, expression level analysis of PSY and PDS associated with beta carotene content in selected Kenya beta melon. Specifically, it was to evaluate phytoin synthase and phytoin desaturase gene expression among Kenyan beta melon accession, and then to evaluate beta carotene content among the same varieties. The first objective, the about the plant material preparation, the seed of 5 beta melon were collected from different counties of Kenya and the Gene Research Institute of Kenya. And then the seeds were grown in Kenyatta Plant Transformation Laboratory. And after growing the plants, the material such as the seed, the stem, the fruit, and the roots are immediately frozen in a liquid nitrogen for RNA extraction and beta and HPLC analysis. And then after we extracted the RNA, we check the concentration of that RNA. We notice that the absorbance ratio of A260 and A280 was observed from the range of 1.8 to 2, considered as good for the genome expression. Later on, we noticed that the 28S and the 18S of RNA bond was intact in the RNA samples. And then, after extracting the RNA, we converted into cDNA. Uh, the considering the gene of interest such as PDS and PSY, and also the housekeeping, which was a Momodica Sharantia cyclophene gene. And after running in Agaro's jail, we noticed that the band of CYP and also the band of the gene of interest, PSY and the PDS, was clear in the jail and can be used for the qPCR analysis. In terms of the results, we noticed that first, I want to mention that the negative control we use for that research is the root samples because of its low transcript level, according to many research. After running the qPCR to check the gene expression of those two genes, such as PSY and PDS, we noticed that the higher level of PSY was found in the fruits, when the lowest gene expression of that PSY was found in the stem. The same result was also noticed when we consider the phyton desaturase. We noticed that the higher expression of that gene was found in the leaf, in the fruit, sorry, while the lowest was found in the stem. The middle expression of the gene expression was found uh, in the stem. This was correlated with the study of Cool and al. In 1918, where he found that the transcript level of PSY and PDS was higher in tomato leaf than in the stem. However, in this study, the expression of PSY and the DS were considerably higher in the fruit. Indeed, PSY and PDS expression rises significantly during fruit development. Sorry, let me go back a little bit. Yes. After that, we consider the gene expression among the expression. The first one I previously presented is the gene expression among the organs. Now is the gene expression among the beta melon accessions. We notice that the higher level of PSY expression was found in the accession GBK 027049, while the fairest was found in the accession Mahia Ventura. The medium expression of PSY was found in the accession 453B and NS 1026. In the same range, we notice that the expression of PDS was in the same level, meaning that the highest expression was found in the accession GBK 027-049, while the lowest was found in the accession Mahia Ventura. The higher expression found in that accession GBK could be due to the varietal differences or the environmental environment factors. And then we can say that the Meru County where that accession GBK 027-049 was initially collected by Genetic Research Institute of Kenya must be the suitable environment to produce bitter melon in Kenya. However, we also notice that the expression of level of PDS was higher than the expression of PSY for phytoin after its production undergoes polyacid transformation mediated by desaturation process by phytoin desaturase resulting in decreased PSY activity and increased PDS activity. We can conclude from that first objective that the highest PSY, phytoin desaturase syntax and phytoin syntax expressions were found in the fruits of the five accession, while the accession GBK 027-048 express the highest level expression for those two genes. And then after checking the gene expression of PSY and PDS among the accessions, we move to the estimation of a beta carotene in a beta melon section. And here, the same samples we use for the gene expression were considered for the beta carotene evaluation. We use the method described by Bowman and al. With some modification. Here, the degradation of the sample were achieved using ethanol containing 0.1% ascorbic acid. Then the carotenoid was extracted twice with hexane, and then the extract was suspended in dichloromethane and methanol. For the carotenoid separation and beta carotene detection, we use Shimadzu or HPLC system, and then the C18 ODS colon was used for the detection. The beta carotene detection was done through a photodiode array detector at 450 nanometer. And then the retention time and UV visible spectrum data was performed by comparing their level with that of the standard to be able to identify and to assign or to calculate the beta carotene content in the different samples. We noticed that the beta carotene content varied between organs and were highest in the leaf and lowest in the fruit, while stem express the medium content of beta carotene. This is similar to the work of Okun et al., where he found that beta carotene accumulation in white beta melon was highest in leaf, followed by stem and flowers, and low in the fruit. The low, we also notice here that the the beta carotene content was found in the range of 17 to 45 in leaf, 5 to 12 microgram per gram, considering fresh weight in the stem, and 6 to 12 in the fruit. we can see that here, instead to get highest level of beta carotene in the fruit, is rather in the leaf we got the highest beta carotene content. This low amount in the fruit could be due to the green states of the fruit when harvested. For it has been reported that the fruit ripening is linked to the esterification of xanthophyll, which is necessary for the beta male or for the plant cell to accumulate more beta carotene. And then the direct exposure to sunlight and also the fruit stage must also affect the content of beta carotene in plant. Moreover, the highest beta carotene amount in beta melon accession in Kenya was found in the accession GBK 027049. This could be due also to the environment or to the Meru County where this accession were initially collected by Kenya Genetic Resources Institute. And we can say that to fight against beta carotene deficiencies in Africa, this accession GBK 027049 must be a suitable accession for this matter. Then we also notice that the beta melon was in the range, in the suitable range for all the accession. And we also notice that the amount of beta carotene found in that research is similar to the one found by Coin oil, but the amount we got in that research was higher than in many commonly consumed vegetable, reference to European database of carotenoid level in food. In the same way, it has been reported that the activity of beta carotene in retinol was, according to the food experience in the world, is just 5 gram per microgram per gram is enough to produce the same activity as 1 gram of retinol in human intestinal. We can say that if that's the case, the amount of beta carotene found in that research are suitable for human dietary needs, meaning that this amount of beta carotene we got in the stem, fruit, and some leaf of Kenya beta melon are enough to fight against the beta carotene deficiency in the world, especially in Africa. Later on, we check the correlation between the gene expression and the beta carotene content to find whether there is a link between them. We notice that the beta carotene uh, content was positively correlated with the gene expression in the leaf and the stem for both PSY and PDS. However, we noticed that the correlation was strong, was somehow positive when we consider the fruit and the beta carotene. We can see that there is a link, correlation link between the between gene expression, PSY, PDS, and the beta carotene in beta melon. Uh, we can say that this result we found here in the fruit might depend also on the fruit stage, because normally, according to the expected results, the correlation between PSY and PDS must be strong in the fruit. But since the fruit has been harvested at the green stage, this strongly affects the beta carotene content in the fruit. That's why the correlation is here somehow low. We can conclude from this objective that the beta carotene content was highest in the leaf when we consider the organs, and the accession GBK 027, 049 when we consider the sessions. And the amount of beta carotene were positively correlated with the PSY and PTS expression. The key finding of this presentation is that the PSY and PTS expression in fruit were higher than in the other organs. However, the highest gene expression was found in the ancestral GBK 027, 049. Then the highest beta carotene content was also found in the same accession, followed by the accession 453B in the range of 6 to in the range of 12 to 45 and 6 to 32 respectively. The PSY and the PDS expression was positively correlated with the amount of beta carotene in liver stem and the fruit. In conclusion, I can say that the beta carotene content was linked with the gene expression of PSY and PDS in beta melon, and the value of beta carotene found in beta melon are enough to fight the beta carotene deficiencies in Africa. And then uh, we can, in terms of study relevance, we can say that the outcome of this study will be used for beta melon breeding and conservation programs in West Africa. And this must help also for improving the plants in terms of the fruit, because many people use it in Asia, the fruit for food material, and the entire plant most of the time is used in Africa for pharmaceutical purpose. Then improving the level of beta carotene in that plant by by plant transformation genome, plant genome editing must be most welcome. I want to thank Jomo Kenyatta University for allowing me, and the Pan African University for allowing me for doing that research, and also Kenyatta University for giving the facilities to carry out that study. And also, I want to thank BioVision Africa Trust and also Caro from, and also Illy IET, where I got not only the fruit and also some knowledge in the way of running on the HPLC work of this study. I also thank Carlo because I got from them the agrobacterium that must, which can help me of improving the plants by checking the transformability, the agro transformability of this plant. My colleagues are there. I thank them for the support, help, advice, guidance, and assistance. Thank you very much, Asante Nisanda. Back to you, Chairman.
Thank you, Dr. Stevenson, for your presentation. So, any questions from anyone? Okay, no questions then. We'll move to the next presentation. The next presentation is Dr. from Sandeep Kumar Lahiri from National Institute of Technology, India. And the title of the talk is Artificial Intelligence Based Model and Optimization of Catalyst in Real Industrial Plant to Simultaneously Enhance Profit and Reduce Negative Environmental Effect. Hello, Dr. Sandeep.
Hello, can you hear me? Hello.
I can hear.
Okay, can you see my presentation? Is it visible? Presentation.
Not now, it was. We've seen your desktop, but now we can't see it. Now, yes, we see your desktop.
Okay, why desktop?
Hello, yeah, hello, Dr. Sandeep.
Yeah,
Yes, we can able to see your screen.
can you see my green screen?
Yeah,
Uh,
green screen. You can make it a full
okay,
screen.
yeah, okay,
Yes, perfect. Please continue.
okay. Thank you very much for the organizer of Catalyst to give this opportunity to present in front of you. This presentation is little bit different than all other presentation from morning. This presentation is how catalyst works in real industrial plant and how we can enhance the profit and simultaneously reduce the negative environmental impact in an industrial plant. That's the main theme of the presentation. This catalyst always, the researchers, the chemists, they build the catalyst in pilot plant, in research laboratory, in R&D laboratory. Catalyst always perform well when it was created, but in real plant, its performance like selectivity, activity is not at par with the pilot plant. Okay, it is always less, it is always worse in real plant, in real commercial plant. So why it is worse, what to do to maintain the optimum performance, that's the main theme of this presentation. Okay, so I start with a case study presentation of a catalyst. So before that, I want to take your attention that all of us know that industry contribution is around 1/4 of total CO2 emission on Earth, and industry contribution is also around 1/4 for global warming. uh, Global environment emergency is no longer a doubt among the researchers, but unfortunate realities of today. Uh, the effect of pollution, we all know, global warming, tsunami, storm has increased, and very soon Maldives, a country, a full country, will sink in few years. pH of earth soil is decreasing, which has a very, very detrimental effect on our health. So these all we know, but what to do, what is the solution, that we don't know. So there are basically two major solutions. One is political solution, where all the leaders, global leaders, come together and do a Kyoto type protocol or any such legislation so that we stop harming. But there is another solution, is technical solution. Can we do something as a technology man? Can we do something to solve this CO2 and global warming problem? Unless this technical solution comes out, political solution will not work. Political solution is not feasible in the 7 billion global population. Only by political solution we will be not able to solve the CO2 emission problem. So we need technical solution. How to reduce the CO2 from air. There are many research papers which are good for publication, but it is not really viable on the ground. There are many absorber, many absorbent available around the world. There are many technical papers which absorb small quantity of CO2, but this cannot be a real solution due to large scale of the problem. Also, we talked about alternate fuel source is the solution, but still now alternate fuel source are not economical as long as petroleum and natural gas are present. Okay, so there is no immediate solutions available, so only disruptive innovation can change the scenario, and for that catalysis play a vital role. So I am focusing my presentation today with a case study. Okay, so case study of a commercial ethylene oxide plant. So as you see, there are two main reaction in ethylene oxide plant. The first reaction is ethylene plus oxygen produce ethylene oxide. This is the desired reaction. But at the same time, there is a side reaction which produce ethylene plus oxygen produce CO2 and water, which is the undesired reaction. We don't want the second reaction, but we cannot avoid the second reaction. So desired reaction is the first one. Desired product is ethylene oxide. Undesired product is CO2. Okay, so ethylene oxide plant take huge amount of oxygen from air, and then it produces ethylene oxide and CO2. So as you see, and this CO2 is emitted to the atmosphere. So as you see, it is taking oxygen and emitting CO2. So the negative penalty on the both sides. So if silver-based catalyst was developed 50-60 years ago for ethylene oxide reaction, and it has a selectivity range of 82 to 78%. So at startup run it is 82. After 3 years it is 78%. So with this 82 selectivity, what it means, 82% reaction will occur in the first reaction, and rest 18% reaction for CO2 reaction. So with that catalyst, this is old generation catalyst, okay, high activity catalyst. So CO2 emitted to atmosphere is 230 ton per annum, and the basis is 720 kTA plant of ethylene oxide, and oxygen consumed is 440 ton per annum. So as you see, huge amount of oxygen is sucked from air, and 230 ton per annum oxygen for a single plant. There are 100 such plants available all over world. Okay, ethylene oxide is a major petrochemical product which used to produce monoethylene glycol, and which is subsequently used for the polyester fiber, uh, which is used to make our cloth. All of our cloth is polyester fiber. So as you see, this is a major petrochemical plant, but the technology is so outdated that it sucks oxygen huge amount, 440 ton per annum, and it is emitting CO2 230 ton per annum. So so what to do? So in 2010, after running 40 years with that old generation catalyst, in 2010, three companies like Shell, Scientific Design USA, and Dow USA, they innovated high selectivity catalyst, and the selectivity range is 91 to 82. So there is a steep 10% jumps of selectivity. So, and this comes after extensive research of 10 years to find a metal called rhenium as ingredient of the catalyst which step jump this selectivity. So it took so long time of 10 years research to make 10% jump of selectivity, which has uh, a disruptive research. We this type of research we need to do, which actually reduce the large scale CO2 emission. Okay, so 10% selectivity jump is very huge in terms of CO2 emission. So innovation was done in a pilot plant of R&D lab, this next generation catalyst. As you see in the figure, that the first generation catalyst produced 230 kTA kiloton per annum CO2. The second generation catalyst optimum will produce, because there is a 10% jump of selectivity, so second reaction got suppressed, the CO2 reaction got suppressed. So it is So CO2 generation reduced drastically from 230 to 211 kTA. But as you see, when this is inside the laboratory, R&D laboratory, so when that catalyst out for commercialization, this next generation catalyst in 2010, when it is out for commercialization, what we find that we actually achieve 221. CO2 is reduced. What we expect that CO2 generation will come down to 211 is not achieved. In actual plant, it is achieved 221 kTA. So there is a again jump of CO2 and expectation is not met. So what to do? So as you see in the right hand side figure, the x-axis is cumulative month. So it has a 24-month life, catalyst has a 24-month life, and y-axis is selectivity in percentage. As you see, the black curve, which is the optimum curve, this optimum curve is selectivity should drop as per this black curve. This blue curve selectivity should drop. But in real plant, this selectivity actually varies. It is not following the optimum curve. In real plant, it is following the red curve. So as you see, the average selectivity is always less than what it was supposed to do, what it has a potential in R&D laboratory, but in actual plant, it is always less. So why like that? Why it is like that, that in actual plant, we could not achieve the best selectivity for high selectivity catalyst. So reasons are many. You know, catalyst performance, which is normally represented by selectivity and activity in real plant, is always found worse than what found in R&D pilot plant or a microreactor. So main reasons are in real life commercial plant, there is a different mass and heat transfer in large scale commercial reactor as compared to pilot plant. Also, there are catalyst poisons in feed gas. In R&D lab, you don't have this type of problem. You don't have a catalyst poison in feed gas, but in real plant, there will be always catalyst poison, some water carryover, some poison carryover will be always there. And then there is a promoter in this reaction, a promoter ethylene dichloride. This promoter is used to increase the selectivity, and this is used as a ppm level. So how much promoter concentration will be in ppm level, that's a mystery, you know. So operator, the actual plant operator or engineer could not gauge that how much exactly the promoter concentration should be. So they run a little bit trial and error method, and suboptimum promoter concentration is the main reason that you could not get the highest selectivity. Okay, and optimum promoter concentration continuously change in a dynamic plant environment. So a engineer is not able to really calculate and maintain the optimum promoter concentration, because it is continuously changing based on temperature, based on some other gas, presence of other gas. So it is continuously changing. So so it is very difficult to calculate and maintain the optimal promoter concentration, and this is the main reason why the catalyst selectivity is red color and not the blue color. So what to do in this case? So in our study, we aims to develop an algorithm which will calculate the optimum promoter concentration in dynamic plant environment. And then ethylene oxide reactor is difficult case to build fast principal based model due to multi-phase catalytic diffusion complexity. You know, in real life plant, the reaction kinetics are not so obvious. Okay, so there is a very complex reaction kinetics going on in real life commercial plant. So it is very difficult or time consuming to build a fast principal kinetic based equation. So in this scenario, data driven model such as artificial neural network ANN, in short, it is called ANN, can be promising. So we can use this artificial intelligence to solve this problem and to build the model from the plant data. So model has been built up from actual running data of commercial plant. Okay, so these are the there are three layers of artificial neural network. At the leftmost layer is called input layer. So as you see, oxygen concentration, ethylene concentration, cycle gas flow, cycle gas pressure, CO2 concentration at the inlet, promoter concentration, work rate, and cumulative hours. These are the input. These are the parameters at the input layer. And then we have a hidden layer. And the output layer, we have two outputs, selectivity and temperature. So now with this structure of artificial neural network, we gathered say 2 years data of plant and we trained this artificial neural network with the 2 years real life production plant data, and we make a two model. One model is for selectivity, another model is for temperature, which is represented by the activity of the catalyst. Okay, so why we use ANN? Because we could not build first principle based model. Okay, and these are the performance of the calculated model. At the left hand side, it is selectivity. Y-axis is selectivity. As you see, blue color is the actual plant selectivity, whereas the red color is the predicted model predicted selectivity. On the right hand side, again blue color is the actual temperature and red color is the predicted temperature. So from both of these figure, you can see that actual plant and predicted model predicted are fairly well matched with each other, and they were following each other. So with this figure, we can say the build model is fairly accurate. Okay, so this is another XY diagram. At the x-axis, it is left-hand side figure, actual selectivity. Y-axis is predicted selectivity. And as you see that all the blue colored dots are around the diagonal. At diagonal, actual selectivity is equal to predicted selectivity. Same thing for the right-hand side, actual temperature versus predicted temperature. Okay, so these are the performance of the statistical performance of the model. The error percentage of the selectivity model is only 0.096%, which is very good considering the noise in the real plant. So less than 0.1% error is pretty good, and the r square value is 0.991, which is also very good. So and right hand side, the temperature model error percentage is 0.058 and r square is again 0.999. So from this error percentage, this is prediction error percentage, means actual versus predicted error percentage. Okay, so from this error percentage and r square, we can conclude that the ANN model is very accurate, and it capture the relationship between selectivity temperature with the reactor input parameters. Okay, so once a model is built, uh, ANN model is built, we go to the next step where we want to maximize, we want to find out what temperature, pressure, concentration we should keep at the reactor inlet so that my selectivity is maximized. But there is a problem. Here we have two objectives. One is we want to maximize the selectivity. At the same time, we want to reduce the temperature, because higher temperature means quickly exhaustion of catalyst. So catalyst age will go up, and catalyst uh, you have to change the catalyst. So we have two objectives. One is first, we want to maximize the selectivity. At the same time, we want to minimize the temperature, but these two objectives are conflicting with each other, and that's why only single objective optimization will be not valid here, because we have two objectives. We want one best of two. And that's why we apply multi-objective genetic algorithm. In short, it is called MOGA, multi-objective genetic algorithm. What it will do, actually, it will make a balance between selectivity and temperature. And MOGA explores all the combination of input parameters within their bound and utilize ANN model to obtain a Pareto front. So let me show you the Pareto front. So this is the Pareto front. Because we have two objective here. So as you see, x-axis is temperature, y-axis is selectivity percentage. The red color is the Pareto font. Okay, so Pareto font, what it means that on the red color, all the points on the red color are really optimum points. So from the shape of the red color curve, you can see that you cannot increase selectivity without increasing the temperature. Okay, so this is what this optimum parameter we should keep in the plant, and this Pareto font also give what will be the reactor input, inlet temperature, pressure, flow, and concentrations of raw material. As you see, there is a one operating point. So from the real plant, uh, what it is depicting is that real plant is far away from the optimum, and that's why they could not get the best selectivity. So this Pareto front will give you that what temperature pressure you should keep so that both selectivity and temperature got balanced, and selectivity is maximized, at the same time temperature is minimized. So what's the benefit? So there are 3-4 benefits here. First of all, we made a ANN model which can be utilized to predict selectivity accurately. This type of model, a data-driven model, artificial intelligence model, you cannot make phenomenological model due to complexity of catalyst behavior and reaction kinetics. So this is the first benefit. Second benefit, that we use genetic algorithm, multi-objective genetic algorithm, which will uh, optimize the operating parameters so that selectivity remains maximum in real-time basis while keeping the temperature at minimum. And then we can build, we have built a optimizer, GA-based optimizer in dynamic plant environment, which can be run every hour in the plant automatically to optimize the operating parameters. And the control room operator need not have to exercise trial and error approach to optimize the promoter flow. It will give you the what will be the promoter flow, best promoter flow, optimum promoter flow. GA will give you, and you have to just maintain that flow. And this will reduce the potential loss of selectivity due to high sensitivity of selectivity with promoter concentration. Okay, so these are the basic benefit of doing all these work, but the real benefit are three. So to build this type of model, there is almost zero investment. You don't need anything. You need a laptop and the operating plant data, which both are free. Laptop is almost available in every plant, and data is also available. But by doing this modeling and optimization exercise, you increase the catalyst selectivity, which means productivity increase. At the same time, selectivity increase means CO2 generation and CO2 emission to the atmosphere reduce. So that means you are also gaining the eco-friendliness. So, and this is the only solution to the industry where you increase profit and you reduce the environmental impact simultaneously. Most other solutions which are normally you see in real life plant, that to reduce the pollution you have to reduce profit also, you have to invest something. Those type of solution is not favorable or not attractive for the plant management, you know. So that's why catalyst research can give you, catalyst research and this type of modeling, artificial intelligence modeling can give you such a platform where you simultaneously increase the profit and also reduce the negative environmental impact. So we have calculated for a plant which we are doing, a 730 kTA plant. So as you see left hand side, this oxygen consumption, this before optimization and after optimization, so there is 976 ton oxygen is reduced per annum, ton per annum it has reduced. That means you are not sucking oxygen 976 ton, and at the same time the CO2 emission has reduced almost 500,000 ton per annum. So you are reducing oxygen sucking, oxygen consumption, at the same time you are reducing the CO2 emission. So these figures are for a Saudi plant where we are doing this exercise. So what is the global benefit? Global benefit is net savings of 500,000 metric ton CO2 emission to the plant. And I want to stress here that this is for only one plant. Actually in world these type of 100 plants are there. All of the plants can install this modeling and optimization uh, optimizer and reduce this negative environment. So this is in short is my presentation. Thank you to give me a chance to present it here. Thank you very much. If you have any question, you can ask me. Thank you.
Thank you. Thank you, Dr. Sandeep, for your presentation. So,
Thank
any
you.
questions? Okay, no questions. Then thank you once again for your presence and presentation.
Thank you. Thank you very much.
Yes. So we move to the next presenter, that is Dr. Daria Nekrosheva from National Research University Higher School of Economics, Russia. And the title of the talk is Potential of Green Chemistry in Smart Cities Renewable Energy. Hello, Dr. Daria.
Hello.
Yeah, hi. So you are the presenter now. Please click on the share icon on your screen.
Mm-hmm. Yes, so can you see it? Well, I will
Yes, it is
show you my
visible. Yeah, yeah.
presentation. Yeah, okay, super. So hello everybody. I'm happy to greet you. Thank you for your presence and for your attention. So here we have a lot of doctors who do various chemical experiments and so on, but I am more an economist. So talking about the green chemistry, and I would like to focus on smart cities today and the renewable energy in these cities and how we use green chemistry there. Yes, and the potential, how much to understand how much green chemistry will be important. So first of all, why would we need to think about this? Yeah, we need to solve different ecological problems that we have, and a lot of countries have made cooperations and agreements. Yeah, for example, the Paris Climate Agreement in 2015. Different countries set carbon neutral target, and to become more eco-friendly, well, countries want to reach 25% of emissions. So, moreover, there is an agreement of International Energy Agency. Well, it's not an agreement, but the strategy, yes, for 2015. And there are different ways how we can reach them, how we can do a neutral carbon society from now, but that's not so important, but we still have it. So a lot of people think about this, yes? So everything, what we do, what I do, and everyone who is here, we are working on this. So that's really important for the world. And what about some numbers? Why cities? Why we focus on cities today? Is because cities consume more than 70% of energy that we produce from all sources, and cities produce the largest number of CO2. Yeah, so it's around 70% as well. So what the world do now? So we set targets for renewable energy sources in energy balances in different countries. Moreover, now we have advanced technologies, and from year to day they're becoming better and better. So we have lower costs on producing energy and higher effectiveness. So we do not need to produce as much as we have produced before.
Hello, excuse me, Sharia madam, you are not audible.
Hello. Hello, Dr. Daria. Your voice is not audible to us.
Yes, madam, Sharia madam voice not audible. Recording is going on, but there is no voice, madam.
Hello, Dr. Daria.
Madam, only slide is moving, but it is not audible. Sharia madam.
Sorry. So can you hear me now? Hello? Hello?
It's not properly audible, madam. Please kindly check your net connection.
That in some cities there will be a lot of energy used for heating, like in Tianjin, Seoul, and Moscow, and
Hello,
Beijing.
Dr. Dania.
Yeah. Yes,
Can
I
you
see.
please share your presentation?
Slide
Oh,
not visible, madam.
Yeah, now slide is not visible and your
Yes,
voice is
audio is
audible.
okay. Yes, exactly.
can you see it now?
No, it is not visible.
Wait a second. Share my screen. Yeah. So
Yeah,
okay. So now you
yes, now
see
it
it.
is visible. Yes,
Okay,
yes.
perfect.
Please
Okay,
continue.
I'm sorry. Technical issues. So yeah, so we see that different countries will use energy for different
Yes.
ways. Super good. So and in some cities like Delhi, Los Angeles, Hong Kong, and Guangzhou that you can see in the right part of the graph, um, more the biggest part of the energy will be used for electricity and for transport, and almost nothing for heating and just a little bit for cooling. So okay, let's move on. Um, so if we talk about like about the sources that are most popular in different cities, we can see that there will be
Dania,
Hello?
madam, excuse me, madam, still voice not coming. Only slide is moving, madam, but there is no voice.
hello. Now you see me, hear me? Can you hear me?
Yeah, now it is coming. Yeah, your voice is coming now.
Yes, there is something wrong. Well, let's try it like like, so can you hear me now? I want to use the microphone, so I hope that you will see me, hear me well. Can you hear me now? Can you answer me, someone,
Yes,
please?
Saria madam, now it's very perfect. Please kindly go ahead.
Okay,
Please
yes.
proceed.
So, okay, thank you so much. So here is the list of the indicators. Yes, I have, well, they're kind of obvious, yes. So they are those indicators that we can get for any city in the world. So, well, is it working now? Yes. So is it okay? Super. Okay, so, and what about the data about the energy? It was the shares of PV, solar, and biomass involved RES energy production. Yes, so the sources for that data I got was World Bank, Deloitte, and official websites, and so on. Yes, so I had all these cities in a rating, and I used a special program to, oh my God, I'm so sorry about this. Let's try it like that. So, so we now have three clusters of the cities. They were grouped by the program, and we can see, for example, that cities like Manchester, London, Birmingham, Tokyo, Paris, Calgary, Toronto, Hamburg, Seoul, and Madrid, they go in one cluster. And because they have some similarity in the data I had, so that means that they can reach the same volume of renewable energy sources in their balances. The same situation for other cities like San Diego, Denton, Chicago, Los Angeles, Singapore, Soderberg, Copenhagen, Adelaide. Yes, it's the second cluster. And the last one, Moscow, St. Petersburg, Novosibirsk. There are some Russian cities. Yes, and Bangalore, Jaipur, Dio, and Nelson Mandela Bay. So, but by the way, the last group of cities, this where we can see Moscow, Bangalore, and so on, it is the first cluster. Yeah, so the second cluster, well, I guess it was, give me a second, please. I have it written here. Maybe. So, well, we can see that when we have these groups formed, for each cluster, there is number that all the cities can reach. Yes, so that's the mean of the percent of renewables in this country, or in the city, I'm sorry. So in each city, there is a forecast. So here we can see, yes, for which city there is, which forecast is that. So we can see that cities from first cluster like Moscow, St. Petersburg, Novosibirsk, Bangalore, and so on, the potential of renewable energy sources is about 26%. And for another group like San Diego, Chicago, Los Angeles, and Singapore, they can reach 36% of renewable energy sources in their balances. And for the last group of cities, they can reach almost 20%. So that's the potential that they can get, all the cities. Yes, so there is a place where we can use the renewable energy. Okay, so moving on. So as we know, renewable energy is not all sources of renewable energy. They use green chemistry. So the green chemistry is used in solar PV energy and in biomass. In world energy production of RAS, solar PV gets 13% and biomass gets 70%. So that's a lot. And other sources gets 17%. So if we take in account all these numbers I've got in previous research. So the projected growth of share of resin cities is 12.64%. So the part of solar PV is about 1.8, and for biomass it's more than 10%. So the medium number will be 12.64%, the contribution of green chemistry based technologies, yes, in energy balances in cities. So how we can improve this research? Of course, we can add another indicators, but they are quite complicated. For example, like political support, infrastructure that the cities have, because like in one city it's very easy to change it, but in another, like in Russian cities, as I know, all this energy system, it was projected like 100 years ago, and it's very stable, so it's quite hard to change it. And what else? We can include more cities and make, for example, econometric analysis, but that's the question about the data, because all the data I was looking for, it's like not about a lot of number of cities, so that's about the gathering this data. And also we can analyze specific cases, but there are a lot of them. Yes, for example, like some cities, they were built initially, they were projected like a city that will be getting only renewable energy sources energy, and other cities, they are older, but we don't know. Yes, we haven't made research if this really is important. Yes, whether it's an important factor or not. Okay, so that's the end of my presentation. So thank you for your listening. I'm ready to answer your questions. So if you
Thank you,
have
Dr.
any.
Daria, for your presentation. So, any questions from anyone?
Okay, maybe there is no questions today.
Okay, I think no questions. So, thank you once again for your presence and presentation.
Okay, thank you so much, Emma.
Thank you.
So,
So, going to the next presenter, Dr. Eleonora Eneghi from University of Udine, Italy. And the title of the talk is Heterogeneous Fenton-like Process over Steel Scale Waste for the Treatment of Landfill Leachate. Hello, Dr. Eleonora. Hello, Dr. Eleonora.
Hello. I sent you
Yeah, hi.
the recorded presentation. If you can
Okay,
use
okay.
that, please, because I
Yeah,
have
yeah,
some
sure.
trouble in the connection.
Okay, then we will sharing the your presentation. Once you need to change the slide, just let us know. We will do that.
Did you find my presentation?
for the possibility to be here and to present my work. And today I would like to present you some interesting results on the heterogeneous phantom-like process for sensitive waste for the treatment of landfill leachate. The main idea of this work derived from the possibility to use a solid waste for the treatment of a real liquid waste. So in a vision of circular economy, use a waste for the treatment of another waste. And we started with the preparation of homemade catalyst and the comparison between the performance of the homemade catalyst and the steel scale waste we use as catalyst. So we perform the characterization of the materials, the catalytic activity utilization, we work on the model solution, the proven solution, and after that we work on the liquid waste and mainly on the landfill leachate. Water contamination is a very important issues of nowadays as the use of conventional wastewater processes is becoming increasingly challenging, mainly due to the presence of biorecalcitrant organic matter. And liquid waste are produced from all the sectors of the society, and they are divided into different groups depending on their nature and their toxicological risk. And there is the need to develop new processes, innovative processes for the degradation of highly polluted waste and very toxic waste, of biorecalcitrant organic waste. The removal of organics can be obtained by using different techniques based on physical processes, on biological processes, or chemical processes. Among the chemical processes, we are mainly interested in the advanced oxidation processes that are methods consisting of highly reactive species used in the oxidative destruction of target pollutants, and the advanced oxidation processes are mainly based on UV light, ozonation, or the phantom activity, the phantom process, the phantom reaction. Phantom reaction is an homogeneous reaction where iron salts can react with hydrogen peroxide for the formation of radical species that can oxidate the organics. But we are mainly interested in this talk. I would like to present you the heterogeneous phantom, that is a modification of the original phantom reaction, and we use a catalyst that is not a homogeneous phase, but is a heterogeneous catalyst, so it's a solid catalyst that can work for the degradation of the organic in the solution. The development of heterogeneous phantom processes should be focused on different characteristics. The method should be efficient, feasible, and sustainable. For the efficiency, we need to focus on the maximum organic abatement, the maximum organic mineralization into water and CO2, and the possibility to maximum the reduction of the toxicity. So we need to be focused also on the formation of byproducts that should be less toxic than the current quality. It should be feasible. We need to work with diverse liquid waste, with highly polluted liquid waste, and should be sustainable. So it should be scalable, cost-effective, and environmental friendly. So we need to focus on all these characteristics in order to obtain the best heterogeneous phantom process. The research project that I would like to present here today is divided in 3 phases. In the first phases, we work on model polymer, the equipment, and we work on homemade catalysts based on iron and copper. And we work on the activity, degradation, utilization. After that, we need to optimize the process variables and to apply the homemade catalyst on the treatment of the real waste. And after that, we want to focus on the use of a solid waste for the treatment of the real liquid waste. So we use the stick waste, we characterize the stick waste, and we use as catalyst in the treatment of oxidation. The materials used in the study are the metallic nitrates, the zirconium hydroxide for the preparation of the eminent catalyst, the stick waste for the real solid waste, as catalyst, the hydrogen peroxide, and as oxidant, and the ibuprofen salt for the preparation of the mobile solution, and the light leachate for as real liquid waste. The lethal leachate, we choose to work with the lethal leachate because it's a complex liquid waste produced when rainwater runs to the landfill site and produce a very toxic and recalcitrant waste. So lethal leachate is very toxic and very recalcitrant, and so it's very important to obtain an efficient process for its degradation. How we prepare the homemade catalyst? By in-situ impregnation of the metallic nitrate over a support, the zirconium support. Then we dry at 100 C overnight, and after that we calcine at 500 for 3 hours. And we characterize all the materials homemade and this waste by several techniques, XRD and PAT. Surface analysis, and we perform a bit characterization also of the chemical activity, mainly by the TOC and COD, that are indirect total organic carbon and the chemical oxygen demand, that are indirect determination of the organic matter, and give us an idea of the mineralization process. And we use the IPL-CMS for the degradation of the product, mainly for the ibuprofen solution. Here we can observe the characterization of the copper and iron-based catalyst, eventually with addition of structure and zirconia. First of all, the surface area. We observe only a slight reduction in the surface area when copper and iron added to zirconia, while the surface area decrease. There is a higher decrease in surface area when there is also the strontium. But in any case, the surface area remain quite good surface area. The XRD profile indicate that there is no phase, visible phase of iron copper, but only of the support, the tetragonal monoclinic zirconium. And this is mainly due to the wide dispersion, the very efficient dispersion of the metal over the support. And so this is a very good point because the higher the dispersion, higher the activity. How we perform the catalytic oxidation? Well, we prepare the sample, we perform the reaction, we evaluate the activity results, and after that, we go through the process of filtration and the stability test. And we work on the station, so we can prepare 6 samples in evaluate 6 samples at one time, and we work on different variables: the pH, the temperature, the catalyst dose, the oxidant dose, and the time. And we perform an optimization of all the variables. Here is the catalytic treatment of the ibuprofen. The comparison for all the catalysts, homemade catalysts, and the blue bar are the optimization, while the red bar are indicate the depletion. And we can observe that better results are obtained for copper on zirconia, with almost more than 50% mineralization and a complete degradation of the ibuprofen. We are working on the more obvious solution. And then we perform the optimization of the variables, modifying the temperature. We can observe that 70 degrees is a very good compromise to obtain very high optimization. We worked on the oxidant dose, and there is the effect, only a slight effect when we increase to the oxidant dose. For the catalyst dose, in this case, the mineralization is not very effective on the dose, and while the pH is an important variable to optimize. We can observe the very different activity, the very different mineralization when pH is modified, and less activity are obtained for pH 5 when we work on copper or zirconia. This is the optimization of the variables when we modify the substrate. We are working now on the landfill leachate. We maintain the same catalyst, the copper or zirconia. And in this case, we can observe again how the pH is the main, very important variable, most important variable. And if we work at pH and changing the pH, we can definitely increase the activity. Also the temperature is very important. We need to work at 70 C to have higher activity. And another important variable is the catalyst dose, while the oxidant dose is less important. Here it's the comparison of the ibuprofen and the landfill nitrate mineralization with the time, and we can observe a similar trend for the model and real solution, and with very high degradation. So copper over zirconia is our benchmark, is our benchmark catalyst with very interesting results. And we try also the recycling of the copper over zirconia because we obtain a very interesting, very good catalyst with a 60% or less amplification of the QC. And we try also to, with the recyclable, we can work for several cycles to maintain the activity. And we also try to work in a two-step process on the landfill leachate to increase the degradation, the mineralization of the leachate. And we can see that after the first treatment, if we add new catalyst, we can obtain a 92% of mineralization. So very remarkable result. And we work also on the quality monitoring of organic matter. And so we apply different techniques like the absorbable organic halogen analysis, the visible and the proton NMR analysis for qualitative understanding of the toxicity of our catalyst, how the toxicity can be modified during the treatment. And we can observe that specifically organic compounds like aldehydes and aromatics can be eliminated during the phantom treatment oxidation. And here it's the aldehydes arrangement. We can see that we can also change the condition. We can obtain around 50% of abatement. And here the visible indicator, the red line is after the treatment, and we can observe that in this region there is important decrease of the 5, indicating that the aromatic compounds are degraded naturally. And it's here the proton NMR. Again, we have observed the acidification of the spectrum and also in the region of the aromatic region. So this indicates that the compounds that are initially present in our sample are modified and degrade, are converted into more simple compounds, and so this can be related to other decrease in the toxicity that was confirmed by the detoxification studies, and with a 50% of mitigation of the adverse effect on by BioSafe. And now I want to focus on the steel scale waste used as catalyst. You can see here the raw steel scale and the pulverized steel. And here are some images of the catalyst. We try to divide it in different particle size, this material, and we characterize the solid waste by XRT, and we obtain. We found that this material is mainly made of iron oxides, wustite, hematite, magnetite, all iron oxides. And here, first of all, we work on the effect of the absorption at different temperature, 25 and 70 C, and we can see that yes, there is effect of absorption on this material, but it's very limited. Only less than 15% of absorption can be obtained on material, and so these are limited effects. Here we have the effect of the thin scale particle size on the TFC attachment, and we can observe that the trend is similar, but obviously we find the particle size, so we obtain different TFC attachment, and higher attachment are obtained for lower particle size portion. The 100 microns is more active compared to the 300 microns. So there is a very important effect on the particle size. So to obtain higher activity, it's better not to use the material as it is, but after milling the pulverization of the material. And here there is a comparison of the lithium nitrate and the ibuprofen solution treated with a different amount of thin scale waste. And we can observe that the ibuprofen solution, for the ibuprofen solution, we obtain a remarkable activity at the gradation of TFC evaporate higher than 80%, and this is not affected by the amount of the catalyst. While for the nitrate, we have a dependence on the amount of the catalyst, but the results are obtained around 1 gram of catalyst. And we observe that again the activity is very high, because we obtain around 70% degradation of the TFC evaporate. So again, a very important result. And here the optimization of the variables, so the factor of pH and the epsilon terms. For the pH, we can observe that pH higher than 7 is not active in the definition of nitrate, so we need to work lower than 5, and we have a dependence, and with the best results obtained for pH 3. But we can also observe that pH 4 is a good compromise between the higher activity and the higher pH. So we can modify the pH. And for the oxygen dose, again, we observe that there is a dependence on the oxygen dose with the best activity for 40 milliliters per liter. So this is important to optimize the reaction variables on this new material, because the optimization can be different from the homemade catalyst. And here is the factor of temperature. Process temperature is a very important parameter, and we can see the difference from 30 and 70 Celsius. And there is a very important increase of the TFC evaporate from 40% to 70%, so the temperature is maintained. Optimized temperature is very important for the treatment of nitrate. But again, we can observe that also 50 and 70 degrees is not so bad. Could be a good compromise for a balance of the activity and the electricity. But we also have to focus on the time. After 30 minutes, the catalytic activity reaches its maximum. So we obtain maximum degradation after 30 minutes. We don't need to treat for a long time the real liquid waste, but we just need a very limited time. 30 minutes is enough for the complete TFC amount. And here we can see what we obtain. This is the nitrate before the treatment, and this is the nitrate after the 30 minutes treatment. So also it's very let's see the very different color, very dark brown at the beginning and a clear solution after the treatment, indicating the remarkable attachment of the organics. So I would like to conclude that the stick waste is a optimized material for the treatment of highly polluted wastewater stream, like the nitrate. And this is focused on the circular economy perspective, because the stick waste is produced in huge quantities and could be effectively used as catalyst in a high polluted liquid waste treatment process. So this is very important because it's a waste and produced in a huge quantity, and we can use it as it is. for the treatment of very high density minerals. And this opened a new perspective for more sustainable processes and for a low-cost treatment for several wastewater streams. So we obtained a very remarkable results. And I would like to thank some of the research group, Subarata and Pacha from the Organic and Inorganic Chemistry Group of the University of Udine, the Marinelli Institute for Technological Research from Milan, Italy, and the Regional Agency for the Protection of the Environment. And I would like to thank you for your attention.
So this is the presentation from Dr. Eleonora. Hello, Dr. Eleonora.
Hello.
Yes. So the presentation is over, which you have sent to us. We have played that one. So
Yes,
anyone
thank
have
you.
any questions? Okay, I think no questions. Thank you once again for your presence and presentation.
Thank you very much. Goodbye.
Okay, bye. So our next presenter is Dr. Prerna Sharma from Guru Gobind Singh College of Pharmacy, India, and the title of the talk is The Pharmacological Activity of Tulsi, Ossimum Sanctum. Hello, Dr. Prerna. Hello. Hello, Dr. Prerna. So, Dr. Prerna is not responding. We have one more speaker from yesterday, Dr. Eleonora Butenko from Azov State Technical University, Ukraine. Hello, Dr. Eleonora. Are you able to present your presentation now? So we will go to the next poster presentation by Dr. Ali Zinodini from Tarbiyat Madras University, Iran. Hello, Dr. Ali.
Hello.
Yeah, are you ready with your presentation? Yes, you are the
Yes.
presenter now. Please share your screen. Phone. Yes.
Do you visible
Yes, we
my
can
screen
able
share?
to see your screen. Yes, yes, you can start presenting. Can you please zoom out part by part because it's not visible? I mean, you need to zoom in.
Uh, Visible my screen share?
Yeah. I'm asking you to zoom in part by part so that we can able to see your content. You have the zoom option on the top right corner.
Yeah. Full screen.
Okay, you can start presenting.
Uh, Title of presentation and research investigation: the performance of spinel material MgX2O4 X equal to magnesium nickel cobalt as potential cathodes in magnesium ion batteries. Other name Dr. Sahila Javadian, Ali Zainuddin, and Dr. Nima Dalir. For many technological purposes require to energy, batteries as energy storage system play a key role in achieving this goal. Magnesium ion batteries have been researched and interested by scientists as a new technology for the post-lithium era. Magnesium ion batteries are interesting due to higher theoretical capacity than lithium and good abundance of on Earth, safety and low cost. But the cathode used in them are considered as a problem in their commercialization. There are several important parameters in choosing the right cathode, which can be maintained as a high capacity and proper stability in line charge and discharge cycles. Uh, Type of cathode used in these batteries that include intercalate conversion and organic. Intercalate is important because of easy study mechanism. Among intercalate spinel cathodes, candidate material because of low cost and easy synthesis. In this research, different type of spinel cathodes have been studied, and their performance and stability have been evaluated. These cathodes were synthesized by the facile one-step self-template method using glycerin as the template. Can be seen in figure schematic of magnesium ion batteries. Uh, Anode in this battery, magnesium and graphite. Cathode include the intercalate conversion and organic. Aqueous and organic electrolyte can be used in these batteries. Insection materials and method. Synthesis method. In this method, for example, synthesis magnesium manganese. We use manganese and magnesium salts dissolved in isopropanol, then added glycerol to solution. Stir for 2 hours. So transfer to autoclave, after autoclave, achieving material centrifuge and placed on furnace. In this figure, you can schematic of synthesis. In the section result, charge and discharge tests for spinel materials have been carried out of the current density of 500 milliampere per gram and capacity of 145, 95, and 17 milliampere hours per gram have been obtained for manganese oxide, magnesium nickel oxide, and magnesium cobalt oxide, respectively. Type of analysis for a study battery include impedance spectroscopy, cyclic voltammetry, and GCD. Can be seen in figure profile of compare GCD MgX2O4 X equal to manganese, nickels, and cobalt. As seen as magnesium manganese oxide is higher capacity rather than magnesium cobalt oxide, and to profile magnesium 6 that's 150, 100, 100, 200, 250 cycles. And show that magnesium manganese oxide spinel is the most suitable cathode for magnesium ion batteries because the magnesium ion diffusion barrier in the structure is lower than other structures. Our research is being done to improve the performance and mechanical stability of this cathode by using doping solutions of transition elements in the structure and composite with carbon and polymer substrate to achieving commercialization goals. Thank you for attention.
Thank you, Dr. Ali, for your presentation.
Thank you.
So, yeah, so any questions from anyone? Okay, no questions. Then thank you once again for your presence and presentation. So we move on to one more presentation we have
Thank you,
that is
Dr.
left
Emma.
from yesterday. Thank you. So we have Prerna Sharma. Hello, Dr. Prerna.
Hello, ma'am.
Yeah, hi. So I'm going to make you the presenter.
Okay.
Yeah, please share your screen with us.
Is it visible to all?
Yes, yes, it is visible. You can make it a full screen.
So, good evening to all. Today, I am Dr. Prerna Sharma, Associate Professor, Pharmacy Department at Guru Gobind Singh College of Pharmacy, Yamunanagar, India. So, my today's topic of talk is pharmacognostic evaluation and pharmacological effect of selected species of genus Ocimum. Now, extraction. How can we extract the essential soils of the Ocimum sanctum plant? The essential soils of Tulsi were extracted by the hydrodistillation using Clevenger's type of apparatus. 200 grams of fresh leaves of Tulsi were put in a 5-liter round bottom flask and was filled with the deionized water up to the third mark of the flask. Electrical heating mantle was used to heat the water. The flask was fitted with Clevenger and condenser. Now, what are the methods and preparation are used to analysis for the analysis of essential soils extracted from Ocimum species? There are several methods. First is by GCMS analysis, that is gas
Hello,
chromatography
Dr.
mass
Prerna.
spectroscopy analysis.
I'm sorry for the
Yes,
disturbance.
ma'am.
Can you please change the slide accordingly as you go on to the presentation? As we can see, we are on the first slide only.
Okay, I will check. Now, now can you see the slides?
No, we are still on the first slide. I think it's got stuck. Once close the sharing and again you can initiate the sharing.
Okay. Is it visible to all?
Yes, now it is visible. Can you make it full screen?
Yes. Is it visible now?
We are on the extraction slide. Is it correct?
Yes. Yes.
Okay, perfect. Okay, you can explain.
Now, as we start with the extraction of the essential oils from the fresh leaves of tulsi, that is Ocimum sanctum, the essential oils of tulsi were extracted by hydrodistillation using Clevenger's type apparatus. 200 gram of fresh leaves of tulsi were put in 5-liter RBF, that is round bottom flask, and was filled with deionized water up to two-third mark of the flask. Electrical heating mantle was used to heat the water. The flask was fitted with Clevenger and condenser. In this, we are going to extract the essentials of tulsi by hydrodistillation technique and using Clevenger type apparatus. Now, there are various methods for the analysis of essential oils. First method is GCMS analysis, that is gas chromatography mass spectroscopy analysis. Now, there are various types of species of the genus Ocimum, that is Ramatulsi, Ocimum graticium, Krishna Tulsi, Ocimum sanctum, and Vanatulsi, Ocimum canum. Essential oil was performed using an Agilent technologies. This was the name of the GC used network gas chromatography system equipped with Agilent Technologies mass selective detector and 76835B series auto injector. The essential oil chemical constituent were separated. Now, a Perkin-Elmer gas chromatography with flame ionization detector was used for the chemical analysis of Rama Tulsi, Krishna Tulsi, and Vana Tulsi essential oils. The temperature of the injector and detector were set at 220 to 290 degrees Celsius respectively. The column thermostat temperature was started from 80 degrees Celsius and raised to 220 degrees Celsius at the rate of 4 degrees Celsius minimum minute inverse, whereas initial and final temperatures were held for 3 and 10 minutes respectively. The carrier gas was helium with a flow rate of 1.5 milliliter minute inverse. Now, antioxidant activity determination of DP pH quenching activity, that is alpha alpha diphenyl beta picrylyl hydrazine. Antioxidant activity of compounds exert beneficiary effect on cardiac system because oxidative stress is closely related to the cardiovascular diseases. DPPH is a stable free radical that can accept an electron or hydrogen radical to become a stable diamagnetic molecule. DPPH radical react with various electrons donating molecule and results the formation of colorless 2,2-diphenyl 1-picryl hydrazine. Reduction of the DPPH radical can be estimated quantitatively by measuring the decrease in the absorbance at 517 nanometer. The antioxidant activity can be expressed as percent squelching and presented by IC subscript 50 value. Now these are the results after performing the testing of the Osmium sanctum extraction or essential oil extracts. So the finding of antioxidant assay using DPPH method revealed that compound have significant antioxidant activity with ICH 50 value 14.61. Ascorbic acid was used as standard and showed IC 50 23.41 as shown in the above table. Discussions. The GCMS study suggested that anethole, which is well-reported antimicrobial compound, is more in Ocimum canum, that is the Vanatulsi, in comparison to Ocimum sanctum, that is the Shamatulsi, but absent in Ocimum gratissimum, that is Ramatulsi. The result indicated that antimicrobial activity is more in Ocimum canum due to the presence of high amount of anethole in comparison to Ocimum gratissimum, Ocimum and Ocimum sanctum. These are the chromatograms obtained after the GC of the different species of Ocimum genus. This is for Ocimum sanctum, this is for Ocimum gratissimum, and at last this is for Ocimum canum. Thank you for listening.
Okay. Thank you, Dr. Prerna, for your presentation. So, any questions from anyone? Okay, no questions. As for today, we have one more presentation left actually from Dr. Vyacheslav Artyushenko from Art Photonics GmbH Germany, but due to some technical issues, he has said that he cannot able to attend. Actually, he attended yesterday and today also, but he tried a lot. So he said that to play his slides of presentation on his behalf. So we will be playing on his behalf, and if you have any questions to us, please write to the program manager. We will ask him to answer those questions. So right now we will share the slides of Dr. Vyashlev. Just one moment so that I can share the slides. So this is the presentation by Dr. Vyaslev. So this was the presentation by Dr. Vyashlev. So this comes to the end of our 2 days conference, and simultaneously we have successfully completed the live conference in Rome, Italy. We have been fortunate to have a great identities from academies, industries, and other areas with us. We'll be glad and thankful if you could join us in our next conference in person or virtually. The dates will be informed to you by email. Also, would request you to provide share or valuable opinion or feedback with us. For any further queries, you can mail to the concerned program manager. Certificate will be emailed to you. Thank you and have a nice day.